Uh, Greeting to you, dear participants of the Computer Science and Software Engineering Workshop. For several years in a row, we have been holding our scientific events in extremely difficult conditions. And this year, unfortunately, is not exception. But we do not lose our resilience and perseverance. Despite the constant terrible Russian terrorist attacks, we will continue to prove that Ukraine not only resists the enemy, but also continues to develop the civilian sector, education and science. In many regions of Ukraine, energy supply is currently very difficult. It is all the more valuable that so many participants join today's workshop. Thank you and hope that you are all well and safe. It's так, well.
According to the workshop program, our first presenter should be Kwan Chon He and his team from Vietnam. But at the moment, I can see here. Andrei Mikolaevich, what do you think that this talk we can down? The next presenter team Василь Олексюк, Іван Грицай and Ярослав Василенко. Ярославе Пилиповичу, все, Василю Петровичу, ми вас бачимо.
Okay, please, запрошуємо до доповіді. We are not hear you.
Yeah, start sharing my screen.
Okay. Dear colleagues, let me to introduce our author. He is Ivan Gritsai. He is a master student of specialty computer science of our university, Ternopil National Pedagogical University, and he will present the main results of our research. Ivan, you have the floor.
Okay, good afternoon, dear colleague and the participants of the conference. My name is Ivan, and today I am pleased to present the result of our research entitled Developing of User Application Module based of computer vision and machine learning technology. The rapid expansion of digital service, mobile access technology, and cloud-oriented infrastructure has significantly increased the demand for secure, efficient, and user-centric authentication mechanism. Traditional authentication approach such as password and PIN code have demonstrated decreasing efficiency due to reliability to disclosure social engineering, phishing, and automate brute force attack. Consequently, a prominent global research trend in the field of information and cybersecurity involves the development and adoption of biometric and machine learning-based authentication system. Within this content, our research focus on real-time face recognition as a natural, intuitive, and human-centered modality for secure user authentication. The primary object of the study is to conduct a comprehensive analysis of state-of-the-art biometric authentication module, methods and frameworks, design and implement modular authentication solution employing machine learning algorithm, ensure seamless integration of module into a web-based software environment with minimal hardware and computational requirement. The research integrates methodologically and technologically components from machine learning, computer vision, web engineering as the software architecture. Modern information system implement 4 major classes of authentication method. It's knowledge base, like password phrases, possession base, like security token or smart card, and biometric face, fingerprint, iris, or voice. And the second one is multi-factor authentication. The proceed solution release of biometric authentication as it provides an optimal balance between recognition accuracy, silence to compromise usability, and minimize of user-related error. The study several experimental key approach used for face recognition. The hack method provides very fast processing and works well for simple frontal image, but its effectiveness decrease in more complex condition. CNN-based module offer high accuracy and better robustness to change light, rotation, and noise. Although they require greater computational power. Advanced embedding models such as FaceNet or RC Face generate high precision for representation, while vision transforms show excellent performance in challenging scenarios, but demand significant computational resources. Consequently, those facts, we select CNN to the most stable model for those implements of the proposed authentication module. The following libraries include in the compatible assessment. OpenCV is high-performance core computer vision toolkit. DLEAP accurate Hawk CNN-based face detection and encoded model. Face recognition high-level API simplifying implementation and integration. Insane face state-of-the-art accuracy and RC face-based embedding. The proposed implementation integration OpenCV with face recognition providing advantages in executed speed, accuracy, maintainability, and development time. The selected approach enabled detection, encoding, and compression using high-level API call. The model requires pre-training before it can be used effectively. Support integrate with OpenCV, NumPy, Flask, FastAPI, and PHP-based system. This system allows locate it in the server and don't use any other cloud services. The developed authentication module features layered service-oriented architecture compression, client-side web interface, capture video frames via browser, get camera access by JS, and transmit them to the server. PHP server-side layer perform requests, data validate, and interprocess communication with ML system. Python-based ML system conduct core biometric operation, including detection, normalizing, embedded vector generation, and decision making. Real-time processing and potential microservice deploy ensure scalability for local and cloud environment. The operational workflow includes the following states: frame acquisition and pre-processing, face detection, generate of 128 dimension embedding, vector compression against reference dataset, authentication decision output. Additional head movement license mechanism was implemented to reduce static image spoofing risk. Experiment testing demonstrate high percentages of recognition accuracy, resilience to light variant and modern head rotation. Stable real-time performance means browser PHP and Python pipeline, and show the small processing timeline. Performance degradation was observed with low quality webcam input and high blur frames. Stress testing confirmed the necessity of transition to asynchronous communication technology, Flask API, Flask and FastAPI for workloaded execution per 50 requests per minute. Testing methodologically include repeated validation cycle across multiple environmental conditions, like such light, angle, and distance to the camera. Both synthetic and real user input streams were used to evaluate system stability and reliability. The researchable result in the development of the functional biometric authentication module based on computer vision and machine learning. Successful implementation of user identification using existing dataset. Empirical verification confirmed real-time operation capability and algorithm correctness. Achieve high accuracy, robustness, and applicability for real-world web-based service. The module may be future deployed in system requiring continuous authentication, such like education platform, corporate infrastructure, and cloud-based service. Future research direction include implement a multi-biometric authentication, develop a mobile optimized deployment architecture, integrate of a transformer-based recognition model, microservices-based deployment with asynchronous processing. Thanks for your attention. I'm ready to answer your question.
Thank you, Ivan, or Ivan, how he introduced himself. We have some technical issues. Oh, Andrei Nikolaevich, we together. Ivan Gritsai complete his talk. We would like to invite all even co-authors of Ivan to the questions. Any questions is a chance to make this result stronger. Don't afraid of the thought questions. Who will be first? Nathan Smolny.
So, you've mentioned that you aim to improve resilience to image spoofing. I know that the same systems were attempted to spoof from videos from games or just videos from other people. Was there any tests performed on spoof resilience? And how they were performed?
We make the system before you start authorization. You must do some actions. These actions can be like
Eye blinking.
some eye blinking and head moving, something like make smile or And this test I will do in different area that's without light and with light. And
And so you confirmed the spoofing resilience. Yeah, okay, I got your point. Thank you.
Thank you, Nathan. Thank you, Ivan. The next questions, please. I have a questions. It seems to be a questions not to Ivan, but his team, Vasil Petrovich and Yaroslav Filipovich, because this is a question about architectural decision. I remember my attempts from the past century or millennium when we use pure CGI and I freely can execute any program on my web server. Your architectural design, you use anything, it seems to be Python software or other software, you do a simple shell exec to run it from PHP. It's no, this century is a question. It's a question of security concerns, scalability, etc. So my question: why did you choose this architecture over no slightly more robust solution like microservices, REST APIs, etc. And how do you handle concurrent requests and private command line injection attacks?
Thanks for your questions, Sergey Alexeyevich. The decision of choosing components of architecture of our authentication model was selected through some reason. First of all, it's Python. It was chosen for the next reason. This language has powerful models for image processing and machine learning libraries. But Python has some disadvantages like requirements for system resources, and its interpreter was doesn't very powerful and quickly. But
yes, Vasily Petrovich, I clearly understand. You don't like Django, you dislike this resource consumptive, etc. But in the typical situation, when you have resource constraints, it seems to be a really good idea to some work to outsource. PHP is fast, PHP PHP can make a good connection server, but the next part it's really be microservice architecture. When some work do, but who can in any cloud at the edge, etc. I see now you try to make a separate part for computer vision and separate part for client server, and you glue it in such way. It's a good zero iteration, and I would like you iterate on the first and the next steps. My question, next question will be not architectural, but no, quite privacy, ethical considerations. Despite you use a biometric data, you can make an image, you transmit it to server, and in some way process. In the main question, how is biometric data encrypted during first transmission, during storage? It must be storage to process your Python software. And what methods prevent different attacks? For example, template extraction attacks. No, my main idea, how have you considered some privacy preserving techniques like homographic encryption or federated learning?
So I say the answer. We encrypt biometric data and save it in the database. When we send data from web page, we encrypted image and PHP server validate it and check it when all data is valid and no any harmful things in this data. And after that, Python make a vector embedding, which encoded by OpenCV library. After that, to save in the database, we encoded this encoded data from OpenCV. We hash it and save to the database.
Thank you for your answer. Please, dear colleagues, the next questions. Andrei Nikolaevich, have you any questions? No questions, so thank you so much for your presentations, for the discussions, but we need to go. Andrei Nikolaevich, who will be next? It seems to be our next presenter, Mykola Khokhlov, here. Mykola, we can see you, but yes.
Good afternoon. Today I will present our research titled Development of Hybrid Optimization and Prediction Approach for Personalization Diet Design. This work focuses on improving how personalized diets are generated using both optimization and machine learning methods. Personalized nutrition is becoming increasingly important Creating a balanced diet requires considering calories, nutrients, requirements, and user preferences. Manual planning is difficult, so automated systems are needed. Our goal was to analyze different algorithms and find the most effective combination for personalization diet planning. To build a personalized diet, we first determine the user's physical parameters. We use BMI and basal metabolic rate calculated with the Mifflin-St. John formula. This gives us the daily calories requirement, which becomes the track for our optimization algorithms. The literature shows that each algorithm used in diet planning has traits and limitations. Learning programming is accurate but creates limit variety. Monte Carlo handles accurately and gives a fixable result. The greedy algorithm is fast but often suboptimal. Genetics algorithms are powerful and provide a large variety of solutions. Machine learning models such as random forest, XGBoost, and MLP improve prediction accuracy. This motivated us to develop a hybrid approach. Our goal was to develop and analyze methods for generation personalization diets using both classic optimization techniques and intelligent methods. We focused on accuracy, speed, variety of solution, and particle applicability. The final result is a conceptual hybrid model. In our experiments, we compared several optimization methods, learning programming, Monte Carlo, greedy algorithm, a modified general algorithm, and general algorithm. We also tested focusing models, MLP, neural network, random forest, and XGBoost. This allows us to identify the strongest combination of techniques. The results show important difference. Monte Carlo is the fastest method. Learning programming is the most accurate. The classic generic algorithm produces the widest variety of diets. The modified genetics algorithm provides the best overall performance, high speed, large variety, and stable accuracy. For setting, XGBoost trains the fastest random forest provides stable predictions, and the modified MLP use the last RAM while giving good accuracy. The combined system, modified JA plus modified MLP, provides the best hybrid approach. In conclusions, our study demonstrates that hybrid system combining optimization and machine learning provides the most accurate and flexible diet design. The modified genetics algorithm genetics device effective meal plans well. The modified MLP offers strong predictive capabilities with low research used. This approach is suitable for integration into real-world diet recommendation system, including mobile and web platforms. Thank you for your attention.
Thank you very much. Dear colleagues, please your question.
I wanted to thank the reviewers for their work. They made some good comments. This work is based on your master's students interested in diets. And we decided to incorrect it into our thesis.
I'm happy to see Yevgen Fedorchenko, coordinator of this team. I have a pair of technical questions. The first, I try to read by diagonal your paper, and it seems to be the your modified MLP shows promise with very, very low memory usage. But how does it adapt over time? Can you elaborate on how the system learns from user rejection or modification of suggested diet plan, meal plan, etc.? Andrei Mikolaevich, I see technical issues prevent to answer my questions. Any other presenter for this talk here was Mykola Khoklov, but no, it's our reality
I see.
and right? Oh, yes, Evgen.
Yes, I hear me.
Yes.
I have a problem internet today. It's a very hard process. We are currently working on new modified algorithms and methods. My students are working and working in diploma and concourse decision new methods and interesting formulas mix standard methods and develop new methods.
Thank you very much. I'm really excited by your modified genetic algorithm. Almost, it seems to be 1,000 diet variants with very good performance. It's a really good result.
Thank you so much. Have a good day.
Good luck. Andrei Mikolaevich, we must go to our next presentation.
Next presentation, Galina Kiruchuk apologize and she...
It's a team from Zaporizhia, Yegor Krynik, Galina and Dmitro Tyagunovi, Alina Kazurova, I'm sorry, Maria and Dmitro Tyagunovi, Galina Kiricek, and Alina Kazurova. They all
Your presentation will be later.
We schedule later this presentation. Our schedule is very dynamic today, as for today. It seems to be our next presentation. Vadim Шкарупіло, Артур Тіменко, Світлана Грушко, and Natalia Kulikovska. Artur,
Good day,
I'm
good day.
glad to see you again.
Me too. 1 second. Can you see? Have you seen my presentation?
Yes, exactly.
Okay, let's go. Good day, colleagues and guests. My name is Artur Timenko, and today I will present our research on modeling and analyzing the performance of IoT systems using IoT SIM Edge and comparative study of data transfer protocols. This work was conducted in collaboration with Natalia Kulikovska, Svetlana Grushko, and Vadim Shkarupila at the National University Zaporizhia Polytechnic. Let me begin by providing context for our research. The Internet of Things is one of the most dynamic areas of modern information technology. According to Cisco estimates, by 2020, the global network reached approximated 50 billion connected IoT devices. However, traditional centralized cloud computing faces critical performance limitations. The main problem include high data transmission delays to remote cloud service, which makes it impossible for real-time applications to function properly. Additionally, the constant transmissions of large amounts of data creates a significant load on network infrastructure and increases the risk of data loss. Furthermore, energy consideration of autonomous IoT devices make continuous data transfer to the cloud inefficient and reduce here autonomous operation time. Edge computing offers an alternative approach by placing computing resources as close to the sources of data generation as possible. This allows for initial processing of information locally, minimizing delays and reducing the amount of data to be transferred to the cloud. To address these challenges, we utilize IoT SIM Edge, a specialized tool for modeling and analyzing the performance of IoT systems with edge computing support. The platform is based on the cloud SIM framework and extends its capabilities with specific components for IoT environments. The architecture consists of 3 main modules. First, the IT devices simulation module, which models the behavior of heterogeneous sensors and smart devices, including data generation, energy consumption, and network interaction. Second, the resource management model, which implements algorithms to distribute computing resource power among components of their 3 IoT edge cloud architecture. And third, the network model, which provides simulation of communication channel characteristics, including transmission delays, bandwidth, and packet loss. A key of future of IoT SIM Edge is comprehensive support of major IoT communication protocols, MQTT protocol, SOAP, and HTTP. As shown in Figure 1, the simulation progress follows systematic workflow from environment preparation thought to result analysis. Before proceeding with our experiments, we evaluated several simulation platforms for IoT systems. As shown in this comparable table, IoT Sim Edge provides full edge computing support with comprehensive protocol coverage, including MQTT, SOAP, and HTTP. It offers detailed energy modeling capabilities and medium scalability up to 100 devices. 1000, sorry. Compared to alternatives like Forge Net Sim++, Edge Cloud Sim, and iFog Sim, IT Sim Edge demonstrated the best balance between functionality and ease of use for performance evaluation tasks. This is practically avoided in its support for multiplayer IoT protocols and detailed energy consumption modeling, which are critical for research objectives. Now let me describe our experimental methodology. The first experiment involved simulation and network of battery-powered smart lamps. We configured 12 indicated IoT devices, each with a battery capacity of 10,000 milliampere hours and discharge for a rate of 1 milliampere hour per second. The data generation frequency was set to 1 packet every 10 seconds. Representing a balance between information relevance and energy consumption minimization. The total simulation duration was 120 seconds, corresponding to 12 data generation cycles for each device. We used the MQTT protocol for data transmission, which ensure guaranteed message delivered through as publish-subscribe model. The network topology included 5 edge servers with a round-robin load balancing algorithm to ensure uniform utilization of computer resources. The system architecture is installed in Figure 2. Next, the second experimental scenario modeled a smart thermostat system with automatic control elements. This system consisted of a smart thermostat as a sensor device and an air conditioner as an actuator. The thermostat measured temperature once every 5 seconds. The thermostat's battery capacity was 5,000 milliampere hour with a discharge rate of 0.5 milliampere hour per second. A key feature was the implementation of decision-making logic directly on the IoT device. When the temperature exceeds 30 degrees Celsius, the thermostat automatically generated a command to run on the air conditioner. Importantly, we used 2 different communication protocols, MQTT and SOAP, which allowed us to conduct a comparative analysis of their performance. The logical diagram of system interaction is shown on Figure 3. Moving to our results, the first experiment with the smart lamp network demonstrated excellent performance metrics. The system transmitted a total of 144 packets. That's 12 devices multiplied by 12 packages, each with 100% delivery reliability and 0 packet loss. The average response time was 42 milliseconds, which a very narrow range from 40 to 43 milliseconds. The small variation of approximately 3 milliseconds indicated the effectiveness of the load distribution mechanism between edge servers. Regarding energy efficiency, the average residual battery charge after 120 seconds of operation was 86%, with individual devices ranging from 75 to 92%. This variation is explained by difference in Intel simulation states and minor variations in network conditions for each edge server connection. The beta understands the advantages of MQTT. We conducted additional performance comparisons with HTTP under controlled conditions. The results are striking. HTTP demonstrated stable but significantly high response times of approximately 4 and 9 seconds for each communication session. In contrast, MQTT protocol showed an average response time of only 0.004 seconds, very short. This means that MQTT is approximately 472 times faster than HTTP. This dramatic difference is due to fundamental architectural features. HTTP requires full connections, establishment, and termination cycle for each transaction, while MQTT used a present connection model with the broker. From an energy perspective, HTTP demonstrated approximately 18% higher energy consumption compared to MQTT. When extrapolated to daily operation, a device using HTTP will perform 12 to 15% fewer data transfer cycle before completed battery discharge. These findings clearly demonstrated why MQTT is the preferred protocol for IoT applications. The second experiment, comparison MQTT and SOAP, revelate interesting performance characteristics. SOAP with used UDP as its transport protocol demonstrate a 40% advantage in response speed with an average of 22 milliseconds compared to MQTT's 38 milliseconds. Additionally, SOAP showed 99% better energy efficiency, consuming 38 milliampere hours versus 42 for MQTT. This achieved third smaller packet size, 28 bytes for SOAP and 47 bytes for MQTT, and elimination of constant TCP connection overhead. Both protocols maintained 100 delivered reliability in our controlled environment. Recharging scalability, as shown in the right table, when we increased the number of devices from 12 to 50, the average response time increased from 42 to 68 milliseconds, a 62% increase. However, even the maximum load the system remained within acceptable performance parameters for the most IoT applications, maintaining 94 transaction success rate. Conclusions. To conclude, our study confirms that IoT SIM Edge is an effective tool for evaluating IoT infrastructure performance without physical hardware deployment. The main findings are clear. MQTT protocol provides stable response times of 42 milliseconds with 100 packet delivery reliability. When compared to HTTP, MQTT achieves response times that are 4 seconds times faster, making HTTP practically unsuitable for real-time IoT applications due to high connections overhead. And SOAP demonstrated a 40% advantage. Our MQTT is response speed and 99% better energy effectiveness, making it optimal for real-time applications with strict latency requirements. Based on the results, we offer the following practical recommendations. Use SOAP for real-time applications requiring minimal latency and maximum energy efficiency. Use MQTT for systems with multiple data consumer where the publish and subscribe model are balanced between performance and reliability are essential. Avoid HTTP in critical IoT applications due to its high connection overhead. For future research, we plan to conduct scaling experiments with hundreds and thousands of devices, investigate different MQTT protocols versions, and simulate real-world conditions with unstable connectivity and network failures. Thank you for your attention. I am happy to answer for all questions you have.
Thank you very much, Artur Valentinovich. I have some personal interest in your talk. As a journal editor, Andrei Mykolaievich is absent today, so I really have much questions. No, first of all, 4,000 times of no, it's a very big gap, so we need a kind of reality check. Your study relies entirely on simulation result from IoT Edge without or with. I don't understand completely. Do you have any validation on real hardware? At least as a small experiment on real hardware to confirm that a so big gap, 4,000 times, is real, is not an issue of simulation or problem or algorithmic problem.
Thank you for your question. Today we use only software IoT Sim Edge. And this simulation software, we use it this principle of experiment first and second. For the future research, we plan conduction scaling experiment with hundreds and thousands of devices. In our experiment, at first it was 12 IoT devices at first, and in second it was beta, biggest devices. At first it was 12 devices, and in second it was we tested only our protocols for using IoT, SOAP, MQTT, and HTTP.
Thank you. The next question about reliability, your simulation software. How confident can we be that these simulation results accurately reflect real-world IoT behavior?
I think we will tested this in our next science publication, maybe.
So for the next science publication, I would like to propose on behalf of the editorial team for the Journal of Edge Computing to make not only simulation experiments, it's really can be expanded, but make the first option to make some reality check on the real IoT hardware, or second options to mathematically ground that your simulation software IoT Sim Edge can get results that fully confirm with reality. That's why the difference in performance is almost 5,000 times between MQTT and HTTP. So a dramatic show. So no, any reviewer ask a questions. Is it not issue of simulation software? Is really so? It's a very big gap. Thank you. My last questions. You report the HTTP response almost 5 seconds. Seems exceptionally high and it seems to appears to represent a worst case scenario with full collection overhead for each request. How representative is this of modern HTTP implementation that use persistent connections like HTTP/2, HTTP/3 with QIC? Probably you use only basic HTTP, but you can compare with modern persistent variant.
We used basic HTTP, and in system of modeling, we fix HTTP and MQTT and tested it in IoT sim edge.
Andrei Mykolayevich is absent, so my next questions. What about, no, again, reality tech? Your paper focuses exclusively on performance metric, but doesn't address security considerations, which are critical for IoT deployments. How do security features like, no, for example, TLS encryption, authenticating mechanism, and protection against DOS attacks rather impact the performance cooperation? So maybe MQTT will be very slow with related encryption. Its encryption layer available to for modeling in the proposed software.
Not available in proposed software, and I understand what you ask. I think MQTT is better than HTTP, and in our work, security is don't use it. Maybe I understand that security is very important in IoT, and in this experiment, not use this topic. Maybe.
Thank you very much, Artur Valentinovich, but we need to go further. Dear colleagues, any other questions to our presenter? Yes, Nathan, your question?
So I have a question. Can you switch to the slide with MQTT and co-op compartment? Yeah, here it is. So here in the first table, you have common packet size of 47 in MQTT and 28 in co-op. Can you elaborate on how this packet size difference is crucial for the power consumption measured? And so, yeah, we excluded 40% of MQTT packet size, and then we said that we have less energy consumption in co-op. Can you evaluate on how crucial this packet size difference can affect energy consumption?
Thank you for your question. I may answer only that. Maybe SOAP implementation application level acknowledgement mechanism on top of UDP. While UDP itself doesn't guarantee delivery. SOAP adds a confirmable message type that requires acknowledgement from the received. But I maybe not understand your question. If answer that not.
Okay, my question was on how we have 40% packet size cut in co-op, and so our radio transmitter or wire stays on for less time in co-op, and so we have a direct correlation with power consumption. And of course, it will impact this metric. Is there an opportunity to simulate this experiment with identical packet sizes?
I think understand. I think it's must to use more more intensive IoT Sim Edge software with size of file to transfer in this experiment.
But you can calculate the average with some simulated exact for MQTT and co-op package size. You have at least a week to improve your paper according to the current discussion, if you want. Thank you, Nathan. Thank you,
Thank you
Artur
for the
Valentin.
answer.
Thank you.
Any other questions? No questions. I hear that we can our presenting from the past talk, game engine impact on hardware resources. Maria Tyagunova, are you ready to present your talk?
Yes. Hi, hello. Sorry for this pause. Yes, we are ready to present our presentation. Just a second. Can we start to share our
Yes.
screen? Yes. So can you see our slide?
We see the slide number 4. So the first slide. Don't hurry, we have a lot of time, both for your talk and any other talks. Thank you.
Okay, so let me start. So hello to everyone. We would like to introduce to your attention the work on the topic game engine impact on hardware resources. The rapid growth of the computer game industry, driven by continuous technological innovation, has transformed games into a powerful medium that extends far beyond entertainment. So today, computer games serve as effective tools for education and skill development, integrating modern data processing and optimization techniques. In particular, 3D platformers demonstrate the generous creative and technical potential through open world design, interactive mechanics, and high visual quality. The accessibility and functionality of modern game engines further enhance this potential, enabling the creation of complex and visually appealing projects. The versatility enables developers to design games characterized by a high degree of interactivity and aesthetic quality. Game engines play a crucial role in this process, offering advanced graphics capabilities and user-friendly tools for 3D game development. Such engines empower even small development teams to create projects with a high level of detail and sophistication. Therefore, research in this area remains extremely relevant for the development of both technological and educational application of interactive media. So the work reviews and analyzes the qualitative characteristics of several game engines that are widely used today, among them Unity, Unreal Engine, Godot, and Redot engines. The research outlines the general concept and key structural components of the project, such as genre, target audience, central idea, main character, settings, objectives, target platform, operating system support, difficulty level, and gameplay duration. The purpose of this work is the development of a computer game in the 3D platformer genre and the systematic investigation of the influence exerted by the selected game engine on computer hardware resources. So the research object is the process of game implementation and a comparative evaluation of its performance across different engines. And the research subject is the performance indicators of a computer game realized on various game engines, which include frame rates, GPU and CPU utilization, as well as the effect of graphical settings on these metrics. To achieve these objectives, the following tasks have been defined. So the first one, to analyze and compare existing models, technologies, and state-of-the-art game engines, to formulate the game concept, to implement the project architecture and user interface along with game objects, characters, and environments. To conduct an experimental assessment of the impact of the game engine on hardware resources. And the last one, to provide the detailed analysis and interpretation of the obtained results in the context of modern trends in computer game development. In this study, the most widely used game engines were analyzed. So the first one is Unity, which enables the creation of projects of varying complexity, is applied across multiple industries, and provides intuitive tools that make the game development process efficient and accessible. The next one is Unreal Engine, which is known for its realistic rendering capabilities, tools for creating large open worlds, and cinematic effects features. The next one, Godot Engine, popular among indie developers and widely used for educational purposes and prototyping. It's free and open resource. And the last one, Redot Engine. This is a multifunctional engine designed for developing both 2D and 3D games through a single interface that provides a full set of tools. So a comparative analysis of these mentioned engines is presented in the table on the slide, and by comparing the characteristics and analyzing the above mentioned game engines, so Unreal Engine was selected for the development of the game, including its main modules and objects. So let's move on. So the prototype creation process is a critical stage in game development, providing initial simplified model used to validate design concepts, test core functionalities, and visualize gameplay ideas and user interface structures. Prototyping supports iterative testing and refinement prior to full-scale production, helping reduce development risks and improve overall efficiency. This stage is essential not only for confirming design decisions, but also for ensuring alignment between the development process and project objectives, so that the final product meets both user expectations and technical requirements. For instance, a high-fidelity prototype of the game settings menu was developed to evaluate interaction and verify functionality before implementation. As shown in the figure on the slide, it includes interactive buttons, adjustable settings, and a user-friendly layout that integrates both aesthetic and functional design considerations. So each game object is implemented with its own logic, including both its visual representation and functional properties. For example, a movable platform object has its own appearance and includes the implementation of platform movement and fall mechanics. The figures on the slide illustrate the logic implementation of the game objects, such as platform fall mechanics, movement mechanics, rotation mechanics, and finish platform logic. The game object chest features a unique visual design and a script that removes it when it falls outside the game area. Its operation relies on periodically checking the object's height coordinate, and once it exceeds a predefined threshold, the object is deleted. And the chest also uses physics simulation, allowing the player to push it and adding some interactive depth to the gameplay. The game object spikes likewise had a distinct design and its own mechanics. Upon contact with the player character, the spikes destroy the character and trigger a level reset. So on this slide, figures illustrate all the game objects that were used in level construction. Base platforms have no gameplay logic and serve solely as surface for the player character to move around on. These platforms are colored green and differ only in size. The starting platform, although classified as a base platform, is colored yellow to visually indicate its function. The player character was created using the pawn class with the addition of the following components: static mesh, camera, and spring arm. The visual appearance of the player character is illustrated in the first figure. Control axes for the player character were defined to manage movement and camera operation. These axes were configured in the project settings, and character movement was implemented using physics simulation. Therefore, it was enabled for the static mesh component, and its parameters were appropriately configured. So on this slide, you can see some examples. So using the created game objects, 10 game locations were constructed. So each game location is implemented as a separate scene. So as you see, here's some examples. So the next step was to monitor the use of computer resources and different graphics settings in the game. Monitoring was performed with vertical synchronization disabled and the screen resolution set to Full HD. For the purpose of research, comparison, and result analysis, the game implemented in Unity 2021 was used. Specialized software tools such as MSI Afterburner and Riva Tuner Statistics Server, so RTSS, were used for resource monitoring. The parameters displayed on the screen are selected in the monitoring settings section of MSI Afterburner. Once MSI Afterburner and RTSS are configured, launching the game will display the chosen monitoring indicators in real time. So the first figure illustrates the operation in the configured monitoring system. The results of the resource monitoring for the game implemented on Unreal Engine 5.4 are presented in the top of the slide, and the results of monitoring the game based on Unity 2021 are shown in the bottom of the slides. So the obtained results were analyzed by comparing the impact of various parameters on hardware resources. A graph comparing of the average frame rate at low, medium, and maximum graphics settings is presented on the first figure on the slide. It shows that the game in Unreal Engine has an average of 1,574 FPS less than the game in Unity. So the next figure on the slide is the graph of comparing of CPU load, again at the low, medium, and maximum graphics settings. And it shows that the game in Unreal Engine loads the CPU by 3% more than the game in Unity. And the last picture is the graph of comparing of GPU load. And it shows that the game in Unreal Engine loads the CPU by 25% more than the game in Unity. So on this slide, the graph comparing of video memory usage by the game at low, medium, and maximum graphics settings is presented on the first figure. For total video memory usage, it's the second figure at the bottom. So these differences are more than 800, more than 900, and 2,500 megabytes, respectively. So the diagram presented in the third figure shows that the game in Unreal Engine consumes 550 megabytes more RAM than the game in Unity. When considering the total RAM usage, it's the last picture, the fourth picture, we can see that at low graphics quality settings, the difference is 832 megabytes. So, as we can see that almost all hardware resource parameters are higher when running the game on Unreal Engine, regardless of the graphics quality settings. Is it low, medium, or maximum? So we are moving to conclusions. So the conducted study demonstrates that Unreal Engine 504 is the most suitable platform for implementing a 3D platformer due to its high graphical fidelity and extensive development capabilities, albeit at the cost of increased hardware resource consumption. Comparative analysis with Unity 2021 showed consistently higher CPU, GPU, VRAM, and RAM usage in Unreal Engine, resulting in lower frame rates, particularly at low and medium graphics settings. Unity showed lower overall resource demand, but delivered comparatively reduced visual quality. So these findings confirm a critical trade-off between visual fidelity and resource efficiency. An informed choice of game engine must therefore consider artistic requirements, gameplay characteristics, and existing hardware constraints. The results provide a solid foundation for further research on performance optimization and engine selection for projects with varying levels of resource intensity. So thank you very much for your attention. And if you have any questions, we try to answer them.
Definitely we have any provocative questions. Thank you, Maria. Thank you very much. Really provocative questions regarding your settings, performance, etc. My first questions. For Unreal Engine, you choose Blueprint. At the same time, when we use Unity, we typically use C# scripting or C++ native programming. Given that Blueprint is a visual scripting system with known performance overhead comparative to native C++, how much of observers performance difference between Unity is good, we believe in this, and Unreal Engine 5, how can be attributed to the scripting approach rather than that itself engine. You clearly show that an additional memory constructed by Unreal Engine can be attributed with Blueprint scripting system. Have you considered implementing the same logic, for example, in C++ for Unreal Engine and Unity to provide a more equitable comparison?
So thank you very much. No, in this work we didn't research the usage C++ for both type of engines. So we used those languages that that are considered for the SE engine. So no, such kind of comparison we didn't do in this research.
It was about software. My next question about your hardware. Your testing, it seems to be a single system with GTX. With GTX, which model? I see. 1050 Ti. It's near almost 10-year systems. You use Windows 11 on the old, relatively old graphical system. How might your conclusions change when tested on modern hardware that can better support the modern Unreal Engine 5 features like Nanite and Lumen? Additionally, have you considered the impact of driver optimization, as NVIDIA historically provides different level of optimization for these different engines?
So actually, in this research, we used those hardware that we have in this moment. So that's why we conducted our comparison, our research somewhere exactly with this hardware. But regarding your question, I think so it will be like for further research. So we will try to compare and to make a conclusion about the impact of the bit modern resources.
Thank you for your patience, for my provocations. And I would like to invite all to the questions for this exciting presentation. Any questions, please?
Well, I have a little question. Have you compared the different version of the same game engine? For example, Unreal Engine 4 and Unreal Engine 5?
No. Thank you very much. First of all, thank you very much for your question. No, but in this work, we compared only Unreal Engine and Unity, but not different version of the engine. No. So as Unreal Engine, it was 5.4.4. Yeah.
Okay.
Thank you, Maria. Thank you personally and your team. Good luck for Zaporizhia and Ukraine. Today, tomorrow, and for a long years. We next to go further. Our next presented. I see Viktor Zhakhalov. Your presentation it seems to be a framework for efficient and secure LLM agency, a case for GraphQL paradigm. Excellent.
Hello, everyone. I hope you can see my screen and you can see my presentation. Awesome.
Yes.
I'm a PhD student at the Department of Artificial Intelligence at Lviv Polytechnic National University. Today we will discuss critical architecture challenges in LLM agency, building systems that are efficient and performant in using tokens and providing quick answers, reliable and secure when interacting with external environments. I propose GraphQL as a principal solution by treating tools as typed and declarative, expressed in well-known to developers and especially LLMs language. I achieve measurable gains in token economy, reliability, and security comparing to current state-of-the-art JSON-based function call. Furthermore, I achieve this result in models that was not designed and trained for function call. The choice of tool calling interface is not a detail, it's an architecture decision that is driven by efficiency, performance, safety, and reliability in production LLM systems and LLM agents in particular. When agents translate natural language intent into concrete action, this interface becomes the bottleneck for the entire system. Today's JSON-based function calling is expensive for LLM to comprehend and generate, while imperative code execution alternatives introduce unacceptable security risks. To succeed in production, we must simultaneously optimize operational cost and reduce time to first token and inference time in total, ensure reliability, validation, and error handling and auto-correction loops, and eliminate code execution vulnerabilities. GraphQL reframes this problem entirely, offering typed declarative queries against strongly typed schemas. Existing paradigm forced trade-offs between expressivity and safety, but GraphQL occupies the optimal middle ground. Imperative languages like Python or JavaScript offer expressivity and freedom and flexibility, but requires heavy isolation because this code must be considered as untrusted. What does it mean untrusted? When you have a code executed in your system, written by somebody else, but not developers of your team, you cannot trust this code. This problem is not solely related to code generated by larger language models, but more to user-provided code. For example, when you host serverless environment, somebody deploys this code should be isolated and sandboxed so it cannot harm your system. And this imposes isolation and operation overheads onto the system. Alternatively, SQL operates at the wrong abstraction level applicable for tools, therefore it can be used in sort of, but GraphQL another option is RPC framework. Typically requires multiple round trips and fragmented validation logic, and do not offer well-known notation and syntax. GraphQL combines rich composition with pre-execution validation endpoint, and also GraphQL offers us within same language package schema definition language that is used to describe the possibility of the system that are available to the agent, and defines execution time language that can be used by the agent to interact with the system. This schema-oriented action space provides native sandboxing, achieving both enough expressivity, and safety without isolation overheads. On the next slide, we see a token comparison. The token efficiency begins with schema design. GraphQL schema definition language is inherently more concise and readable than JSON schema. To be honest, development frameworks that works with JSON schema-based function calls often propose a way for developer to avoid writing JSON schema directly, but rather using Pydantic, if we talk about Python, or Zod schema, if we talk about JavaScript frameworks. For identical capabilities, JSON schema required 112 tokens, whereas GraphQL alternative requires only 61 tokens to describe the same capability of the environment. Therefore, it is 45% reduction. And the larger schema, the more economy we can see. Schema definition appears in every prompt context, so its syntactic efficiency compounds across all operations. When agent access dozens of tools, this creates substantial recurrent savings throughout the system operation, even if we consider Kryvyi caching, because no matter we cache it or not, we still have these tokens in the prompt. Operational efficiency demand reliability requires deterministic validation before execution, and GraphQL provides strongly typed constraint for every operation at a unified endpoint. The schema itself documents allowing agent introspection for available capability. Most critical, GraphQL validates every query against the schema before execution, preventing runtime errors and providing deterministic, well-known feedback. This validation enables reliable self-concern correction with essential for autonomous agent behavior. Operational efficiency demands minimizing round trips and token overhead. For representative tasks, fetching users and orders, JSON function calling requires 63 tokens and does 2 calls. GraphQL accomplishes the same task in 32 tokens, which is almost a half reduction within a single call. Efficiency comes from nesting data in one round trip and ability of GraphQL to execute multiple operations at the same time. Excuse me. Autonomous agent must recover from errors without human interaction, and schema validation creates self-correction agent loops. Every query validates before execution, rejecting incorrect queries immediately. Failed validation returns in standardized machine-readable errors that LM can parse and correct iteratively. Agents can introspect schema itself, create an ambiguous capability map, eliminating trial and error exploration. This enables true self-balancing without human intervention. So, key takeaways. GraphQL provides efficient gain. In my experimentation, it gains almost, on average, 29% reduction in operation token directly, including schema, queries, and responses. Assuming responses uses also JSON. Directly lower costs and improve latency. Reliability improves through validation strongly typed schemas, enables autonomous error correction and self-healing loops. Security is structural, non-procedural schema-bound action space, eliminates arbitrary code execution. GraphQL successfully balances expressivity, efficiency, and safety for production environment. Production system requires a unified approach that addresses all three challenges simultaneously, and GraphQL occupies the middle ground. Unlike imperative Python or JavaScript code that offer maximum risks at a cost of offering maximum expressivity at a cost of risk, or fragmented JSON RPC require multiple round trips and usually not standardized, GraphQL combines rich composition with pre-execution validation. It centralizes authorization at a single endpoint. The schema constrained action space provides native sandboxing and isolation, achieving both expressivity and safety without heavy isolation overheads. So a few words from experience, because this approach is not only theoretical, this approach is applied in a company called OneReach. We use it as a backbone for our agentic framework, agentic platform. We see a lot of economy and a lot of performance boost when we use this approach in comparison to, let's call it, industry standard function calling using JSON schema. And maybe the funniest part, the biggest economy comes from quotes, because in JSON, everything is wrapped into double quotes, and this is the biggest token consumption actor. Thank you for your attention, and I'm happy to answer your questions.
Thank you very much, Victor. I will start with a Q&A session. Just now, at the moment, my Cloud Code in console, both in Cloud Code in web, burn my tokens. Burn my tokens using at least one of the industry standards, entropic JSON scheme, not GraphQL. When I will use another providers, I will use OpenAI compatible scheme with JSON. So we, as a user for this technology, I really will like when GraphQL can make my token consumers cheaper. But we have some reality. What about GraphQL ability to self-correction, self-healing? While specific validations errors allow for self-correction, possible is the risk of agent entering a kind of correction spiral. It will be burning tokens on multiple failed attempts to certify a strict schema. From time to time, at least every 5-7 minutes, I go to my Cloud Code console and attempt to correct these multiple attempts with my repository. So it's under my full control. While we read a prospects from different solutions, the main idea, multiple hours of autonomy coding. But in fact, we need a human in the loop. So I return to my questions. How you measure it? The break-even point where the cost of these self-corrections loops exceeds the saving gained from more efficient initial query structure.
The idea behind my self-correction is not so on when model driving itself into, as you said, self-correction spirals, because the self-correction spirals is a matter of, as it's called now, few shot in the leg, when model tends to repeat what it sees in the context and trying to repeat its behavior. Yes, I faced this problem, and the solution was very simple. I forget that the model tried, failed attempt. If we talk about correction of execution phase, it happens really rarely, and honestly, I didn't account any self-correction loops since Llama 3.3 model. Not talking about larger models. So my initial idea was to turn LLMs that wasn't trained for function calling into LLMs that can execute function calling and therefore can be run locally or can be run very, very cheap. If you talk about self-correction, in JSON style function calling, there is no embedded self-correction at all. It just occurs very, very rarely that model generates incorrect JSON, but it does generate. Usually, it is up to developer or up to developer of the agentic framework to deal with this error. For example, Vercel's AI framework does it. It does validate whether the model generated correct or incorrect code, but not natively. This is a structure overhead introduced by the developer of agentic framework. Whilst in my case, this is not natively, of course, it's somebody developed it, but natively GraphQL cannot be executed by any server. For example, if we take Python Strawberry or lots and lots of JavaScript implementation of GraphQL, these frameworks will validate whether query correct or incorrect before execution. I hope I answered your question.
Thank you, Victor. And one another question regarding your slide. How much agents you use to produce your slides presentations, or you use a simple query with human in the loop?
I do use human in the loop for whatever I do. I honestly could not embrace live coding if this is part of what we're talking about. Yes, this presentation is generated. I used Manos for it, but beforehand, I described all of the slides. As next, I asked Manos to generate more or less acceptable version, and after I edited it manually in Google Slides.
Thank you. My approach not so simple. Usually, I ask some agents to write prompts to generate according to the text, and in the concurrent communication to select best approach and even join them. So you freely use your cutting edge technology even for such tasks like to prepare your presentation, to prepare the so-called text of your PhD thesis, etc. So human at the start, you set a query, human in the loop, it control the result, and human is responsibility who will be defend this thesis. Thank you very much, dear colleagues. Your questions to Victor? Andrei Mykolaievich, have you any questions?
No, I have not questions.
Thank you one more time, and we will wait it for continuation of this work. I believe that GraphQL will be not only schema that validate the request, but it will be natively in the next attempts of our AI giants to make more efficient communications between both AI agents and AI-supported, AI-augmented people. Thank you very much.
I hope to be a first in this race.
And I see who our next presenter. Nathan Smoley, Victoria Smoley, and Alexander Rolik. Who's ready?
Smoley and Nathan is ready. Wait a second, I'm sharing the screen. So now you can see a presentation. So, thank you for an opportunity to participate in this workshop. This presentation will be on the topic of basics of funding a system for detection, accounting, and visualization of explosive objects. The research was carried out by Alexander Rolik, Victoria Smoley, and Nathan Smoley. Then, terribly sorry. So, in this research, we were aimed to propose a decision for building up a system with possibilities of detailed open field survey in order to detect and memorize places of explosive objects. This System architecture was proposed with the usage of infrared radiation sensors, which provided the capability to scan and register thermal anomalies on terrain surface. In order to achieve the goal of careful land research, an approach with subdivision into square cells was proposed. In order to move from elliptic or circular camera field of view to a square survey cell, coverage of camera field of views was examined. As it can be seen from the figure, 3 examination areas, designated as A, B, and C, make the following areas separation. In area A, a survey cell was outlined in the form of an inscribed square, within which multiple subzones were classified based on visibility and cover geometry. The classification will differentiate the following areas. Green, guaranteed good review zone. Yellow, cross-examination from 2 neighbors zones. Blue will not fall into the guaranteed good review zone. Red does not fall into the normal review zone, and cross-examination zone. So, a sequence of challenges for designing a system to fulfill mentioned purpose was examined and divided in sets of smaller problems. This allowed to determine general problems of overcoming every major step of design. The obtained problem tree alongside with major problems are depicted on the slide. From this slide, it can be seen that estimating required distance from object to camera can be performed with previous measures of camera's focal length and setting desired object size to a constant value. Here is the geometrical representation of the worst-case simulation for object detection inside of gullies, ravines, and ditches. The red area on the figure represents object desired for detection in the form of a set of pixels of specified width. So the computation results for a targeted set of parameters are depicted on the slide, as well as obtained result of target height. The result obtained demonstrates the dependence of the required UAV flight altitude on the camera's angle of view and focal length, which allows adjusting the UAV flight altitude depending on the installed video camera, its field of view, and resolution. It also allows you to plan trajectories and missions durations when conducting research and directly plan missions based on the maximum possible coverage of the territory. The dependence of the focal length on various parameters was investigated. Figure A demonstrates the dependence of the flight height on the focal length and viewing angle of the camera. Figure B demonstrates the dependence of the slide of the viewing area cell on the focal length and viewing angle of the camera. So, the further research was dedicated to the tests with defined distance from a camera. A coordinate grid was drawn. A program to perform transformation of grid points into coordinates on the screen was written. As it can be seen, the perfect camera calibration was not achieved, and so cumulative error while projecting point further from the point of projection of camera optical axis persists. Also, a set of samples from open sources was gathered in order to acknowledge with the challenges of video processing. As it can be seen, with the lowering over the ground, contrast in image lowers due to camera's auto-adjustments. This may cause problems while performing surveys, but in order to establish a proper balance between flight height and picture quality, further research must be carried out. Also, it must be noted that the research was funded by the National Research Foundation of Ukraine. That is the end for my presentation.
Thank you, Nathan. It was compactly and full of insights. So I hope this presentation invited to at least some questions. So, no questions. Oh, mm, uh, so I need now temporary chair to make attempt to generate some questions. I'm sorry. No, for example, your paper mentions the metallic objects accumulate heat differently this round is terrain. But how does your system perform under varying environment conditions when the metallic objects be more cold or the same temperature as the ground? Moreover, they can be under small it's dust it's small ground 5-10 millimeters and we have almost no almost
Insignificant contrast.
Oh, yes, statistically insignificant. It's a reality check. How you can to solve this problem?
So the general method comes from a phenomenon of different like energy capacity of the common ground and ground with injected metallical objects in it. Indeed, there will be difference if it is covered in some sort of dirt, grass, and so on. But the temperature over the day isn't static, and so there is a period of temperature rise over the day. It's still the noon, or it must be studied further, or and a temperature decrease at the evening. And so during these periods of time, due to different energy capacity of land areas, areas with metallical objects will heat up and cool down much faster than the rest of the ground, even if this metal object will be covered with dust and dirt. Also, it was shown on the figure that how a camera performs, and also in this figure on this slide we depicted how we aimed to solve problems when metal objects are not completely like perpendicular to main optical axis of the camera.
Thank you, Nathan. You attempt to solve the classical problem using one sensor approach. It really can be done by a multi-sensor system. And one more reality check. Your vehicle have a very low flight altitude, 1 meter or 2 meters, and you need no, at least some 5 or 7 pixel minimum object representation. So in case of a real almost 2,000 square kilometers of our ground in Ukraine are potentially contaminated territories. How this envision approach can be scaling? What is the realistic time and resource required to solve even a single agricultural field? And how does this compare to traditional demining methods?
Well, in order to compensate for the low altitude and small area of coverage of camera, an approach with multiple UAVs was proposed. So, the infrared camera is quite a cheap attachment to the UAV, low cost. We are talking about low cost solutions that can be scaled up by the numbers. Traditional UAV can be quickly rearranged into a UAV with infrared camera, and then this camera can transmit to a local server which will handle image processing. For one specified field, a set of UAVs can be targeted, like 16 fields. It is dependent on radio frequency separation for a specified set of UAVs, and so a lot of UAVs may survey a much wider area in a shorter time than a set of like ground UAVs that will use another equipment.
Thank you, Nathan. But I propose that you probably can fully reimagine this situation. For example, we have a real deminer. A real deminer, it seems to be can be human. It can be human supported, but a set of robotic system. And a human have in his equipment a kind of edge processing device. Some UAVs 4, 5, 100 that support a human while demanding. It can generate in real time the indicators that can help both people and heavy robotics to the mine. Probably not only flying approach.
Yeah.
But this on the future, probably. Andrei
Yes.
Nikolaevich already with us and fully equipped, energy equipped. Have you any questions to Nathan?
No, thank you. I have no questions.
Andrei Nikolaevich, we can't hear you.
I have not questions.
Oh,
Thank you.
thank you very much. Dear colleagues, any other questions? No questions. So, Andrei Nikolaevich, could you invite our next presentation?
Well, 1 second. I see Anna Zemlyanichina. Please, are you ready to present your research?
Yes, just 1 second. Can you see my screen?
Well,
Yes.
Yeah, good. So good afternoon, dear colleagues. My name is Hanna Zemlyanukhina, and I want to present to you our work, which title is Arduino-based chaotic generator with polar attractor. So nowadays, control theory is gaining popularity due to its use in various areas of engineering and scientific applications. It becomes possible due to the significant advance in mathematics, which allow us to construct precise models and algorithms. The main feature of such models, which are based on ordinary differential equation, is the possibility to study both regular and chaotic motion that define the dynamics of various technical systems in different applications. One of the most important applications in the road planning for autonomous mobile robots, which finds its use to solve different tasks. Depending on the performed task, robot motion should be regular periodical and irregular chaotic ones. The last motions are produced using chaotic systems showing complex, unpredictable behavior that depends heavily on initial conditions. These systems have been studied for decades, often through the analysis of their attractors. Most known integer and fractional order chaotic attractors are self-excited.
I'm sorry, Anna. We see only title slide.
Oh, yes. Just a second. I will finish the phrase. Thank you.
Sorry.
Thank you. That's okay. Yeah. A little bit long. A little bit long beginning, yes. Their basins of attractions are connected to unstable equilibrium points, so this property makes them easier to find. A small disturbance near an unstable equilibrium typically excited the attractor, so as a result they are well understood and widely used in a modeling and design. In contrast, hidden attractors are much harder to detect, so their basins of attraction are not connected to any equilibrium, and starting a simulation starting a simulation near an equilibrium will never reveal the attractor. Hidden attractors were discovered only in the past decade. They have sparked interest because of their surprising and sometimes dangerous behavior. In mechanical systems, they can cause unexpected vibrations. In electronics, they may lead the unpredictable occasionally. In secure communication, their unpredictably can be used as an advantage. So studying hidden attractors helps us understand the full range of behaviors a system can show. It also forces us to improve our simulation techniques. New methods for detection hidden attractors are being developed, including analytical approaches and refined numerical searches. These tools are helping researchers uncover attractors that were previously missed. So to study and design one class of chaotic systems, we solve the problems which are shown in the slide. Solution of first two from these problems allows us to build strong mathematical background for system design, analysis, and implementation. The next problem solution demonstrates the use of proposed approach. In our paper, we consider the generalized first-order time-delayed dynamical system. It is a well-known fact that under certain conditions, such system generates chaotic oscillations. Also, we considered some polar curve and used coordinates transformation to define Cartesian coordinates of system representative point in this curve. curve. These coordinates consider as some observability equations for the studied dynamical system, and they can be differentialed to obtain differential equations only. Since the usage of differential algebraic equations have some problems in applying methods for study system motion. Since the defined in such a way motion equations depends on system angular position and speed, it is necessary to solve the system equation in polar coordinates before solving equation in certain Cartesian ones. It can cause the use of additional computational resources and slow calculations. To avoid this drawback, we offered to define system angular position as function of its linear position and rewrite motion equations only in terms of system linear position. The obtained in such a way system can be considered as consisted from two subsystems. Since systems angular position can be represented by using both vertical and horizontal system coordinates, we offer to define interconnections between subsystems by rewriting second summands in system equations. One can use one system position component in this case and define asymmetrical system motion equations and use both of them to define symmetrical interconnections. Since nowadays most of systems are implemented by using various digital devices, we performed a transformation of the designed continuous time system into discrete time domain by using approximation which are shown on this slide. In this slide, we show the designed discrete time models with and without channels interconnections. We showed the studies make Mackey glass system, which we use to illustrate our approach. Also, we define polar curve as cardioid curve and define interrelation between polar and Cartesian coordinates. This slide, you can see a Mackey glass system model in Cartesian systems. So we show the simulation results for such a system in terms of its state and output variables. On this slide and the next one, we show system evaluation as function of weight factors k, which defines the part of performed polar curve. As one can see, increasing of this factor makes system output more unpredictable, although its phase portrait is still defined as cardioid curve. So to prove the chaos occurring in the classical and the design system, we study influence of system parameters on system dynamics and define the areas of chaotic motion, which are shown in the given bifurcation diagrams. The conclusion about our study are shown on the slide. The main of them is proven a possibility to design novel chaotic systems by using nonlinear observability equations. Thank you for your attention. If you have any question, I will be glad to answer you.
Thank you very much. Please, dear colleagues, your questions. Well, my little question. One. Why was Arduino platform was chosen?
First of all, it's available and it's not it's cheaper variants of experimental part of making experimental parts. Definitely we can use in other controllers, different stem or TIHAs, it doesn't matter. The biggest advantages of Arduino, it's firstly availability. the price, and secondly, it's just 8-bit system, so it's easier to program in.
Thank you.
However, we have some issues from such a cheap system. I attempted to read, no, again by diagonally, your paper and found a statement that your implementation on Arduino Duo was with 10 milliseconds. Oh, yes, 10 milliseconds
Yes.
sapling time. However, a number of your questions you demonstrated during presentations contain multiple transcendental functions, not only classical, sinus, cosinus, but square root, arccosinus, arcsinus. These functions are computationally expensive. So, how does computational complexity scale when implementing more complex polar curves and what strategy would you recommend for optimizing real-time performance on Arduino Duo or another resource-constrained embedded system?
Probably it will be better to use another one because the Arduino is not fast enough in calculating operation, so it will take much more time and it will give much more error in the results.
Probably can be used some blended approach when the calculations can be done on some cloud service with small time of response and high productivity, and Arduino has network connections with such services, probably of microservice architecture, etc. Arduino Duo allows such distributed work, so hard computationals can be supported by another devices, and you use Arduino with int4 related calculations. No, it's only proposal.
Yes, it's future research hour. Thank you.
Thank you. Any other questions? No questions. It seems to be not a questions, but some ask when you will revise your paper. Can you make related links? For example, on the your Arduino implementations and on the papers that discuss such issue like heavy computation on the edge devices. At the moment, the most of reference in your papers, more than 15, are related to the mathematics of your paper. But we ask some for software and hardware
Sure.
supported your research.
Thank you. Okay,
Thank you. Thank you very much.
Well, I want to invite our next presenter, Dmytro Badnenko. Are you ready?
Yeah, I am ready.
Oh. Okay, Sergey.
Can you see?
Yes, yes.
Yes.
Okay. Okay. Hello, everyone. So our topic is the development and application of VBA macros in teaching of science and mathematics. In modern education, a crucial task is to enhance the effectiveness of learning materials by using digital technology tools. One such tool is Visual Basic for Application, which is built into Microsoft Office packages. The study examines how VBA macros in Microsoft Office can improve the presentation and visualization of educational materials in science and mathematics. It explores VBA's didactic and technical potential, explains methods of using macros for visualization, provides practical examples, and evaluates the benefits and recommendations for integrating VBA into teaching. From theoretical perspective, the introduction of VBA is in teaching disciplines aligns with modern approaches to developing students' digital competence, fostering algorithmic thinking and promoting interactive learning. The theoretical basics also includes the idea of integrating automation tools into various educational disciplines, ensuring interdisciplinary connection and particle focus on education. The research was conducted at the Boris Glinchenko Kyiv Metropolitan University between March and September 2025. 12 lecturers of science and mathematics participated in the study, including 3 as experts. The method of using VBA as a means of didactic visualization is based on idea of changing the states of Microsoft Office graphic object implemented in a document. The idea behind the method is based on the technical principles of the VBA application. These principles are related to the capabilities of the programming languages built into Microsoft Excel, Word, Access, and PowerPoint Office software. According to the principle, we have text fragments and other objects whose properties we are unable to change. A text fragment can change its color and intensity depending on whether it's in focus at a given moment. This is achieved by executing the corresponding VBA macro associated with this fragment. Other objects, usually graph ones, come into focus or leave it by changing the transparency of the masks related to them after executing one of 2 or 3 VBA procedures. Let's talk about examples. Here we can see example from the discipline differential equations. Here is the fragment of the lecture original document. Here we can see the brightness of the text has been changed with VBA procedure, making it visually less relevant to the observer, and our formulas highlighted on the document. This method shifts the audience attention to a more visually distinct paragraph. The brightness of the text can be reduced or increased at the lecturer's decision. The next example is as follows. Here we have some formulas inside the text. Yes, so we can change transparency of the text, and so our formulas highlights. Note that formulas typed with and Microsoft equations. Here we apply transparency to formulas within the text, and so our main formulas highlighted the most. In most cases, we can't tell if this formula typed using Microsoft equations or it's a picture. So we recommend overlap our formula with a shape object, for example, in the form of rectangle, so that it completely covers formula image. And then we can blend it with our background, with our document background. In this example, we have changed color of the figure to white. Another example from the physics. Let us demonstrate the scaling capabilities of our technology using an example from physics material that contains large illustrations. We have a task from electricity and magnetism section. In this task, the key points are highlighted in bold as is provided. As we can see, the example features a large illustration consisting of 3 blocks, which the author of the material intends to bring into focus at certain moments during the presentation. We will place 3 number objects of the rectangle type so that they cover each fragment of the large image separately. We will attach 3 procedures to each of them. One makes the object transparent, the second makes semi-transparent, and the third makes it opaque. Our research results. In March 2025, we surveyed teachers to gauge their experience with using WebAR macros in teaching science and mathematics. It was found that all 9 teachers lacked the necessary knowledge and experience. At the same time, in identifying the possibilities of using macros in teaching process sparked the teachers' interest in further professional development in this area. As a result, we developed a professional development program entitled Development and Use of WebAR macros in Teaching Science and Mathematics, which was implemented in March till April 2025. Here is the course structure, Model 1. Introduction to WebAR, the role of macros in modern education, the WebAR interface in Word, Excel, and PowerPoint, creating your first macro, automating a simple action. Second model, WebAR basics, variables, operators, conditions, loops, working with Microsoft Office objects, debugging, and testing code. Model 3, WebAR as means of didactic visualization. Model 4, automation of calculations and modeling. Model 5 and 6, you can see. At the end of course, teachers were asked to complete a creative project. To do this, they had to complete the following tasks: choose a topic from their discipline, develop a short teaching document, table, or presentation containing text explanations, formulas, or images, didactic elements that require students' attention. Use WebAR to create interactivity such as highlighting essential text fragments. Format the document so that the teachers can easily demonstrate it in the class. Experts evaluated the implementation of each project according to the criteria, 100 points in total. You can see on the screen how these points were distributed. And it was found that all teachers receive relatively high scores ranging from 73 to 92 points, which according to experts can be considered as positive learning outcome. Here we can see replies or reviews to the course from teachers that participate in it. As a result of our research, we have developed methodological recommendations for use of WebAR macros in teaching science and mathematics. First, project design. From model to educational tool. It's advisable to start developing materials by building a basic model of a phenomenon. Using WebAR as a supplement, not a replacement. Using ready-made add-ons to get started. At the initial stage, it's available to use proven add-on packages that demonstrate standard analysis and visualization procedures while lowering the barrier of entry for teachers. So, conclusions, summary. WebAR macros effectively integrate digital technologies into teaching science and mathematics by enabling didactic visualization, controlling document elements, and varying how information is presented without altering the document structure. Second, the method relies on simple techniques for modifying objects like text or images, helping focus students' attention and allowing lecturers to adapt materials or create interactive resources with minimal effort. So the next you can see, and thank you for your attention. Any questions?
Well, thank you very much. Please, questions, colleagues. Well, I'm first. Currently, Microsoft 3065 is the most affordable license for educational institutions. Have you checked whether VBA scripts will work correctly in this environment? In cloud environment?
Yes. Yes. So we said in the paper, so we can't control, we can certainly tell if the formula typed with Microsoft equations or it is an image. Yes, so we can certainly tell that text is a text. But with formulas, we recommend using the second method, which was shown in differential equations. So placing masks on formulas and apply transparency to it. So you can see or focus on the text or formulas if needed. Yeah, it works.
Okay, thank you. Another questions, please. Okay, well, thank you, Sergey, and another authors for your research. And I want
Thank you.
Invite next presenter. It's Andrei Doroshchuk. Well, are you ready? Please.
Yes, can you see my screen?
Yes, yes. Right.
Yes, my name is Doroshchuk Andrei. I'm from Odessa Polytechnic National University from Department of Software Engineering, and I want to present you the results of my study, colorimetric assessment of visual color difference between interface elements. So let's see the problem statement. It's important to choose the colors appropriately when creating web interfaces and other multimedia content. And some previous researchers were concentrated on assessing subjectively how do users choose color combinations. The aim of my paper is to propose an objective color metric for this purpose, which is based on colorimetric formulas, which are already widely used in image processing and other industry. First of all, let's dive a little bit into theory. During some experiments conducted in the last century, it was discovered that the perception of color is not uniform in different areas of color spectrum. And there were built some ellipses, which are called after the author of original paper, David McAdam, which show the perception of colors in different areas and shows a border between distinguishable colors and those which are non-distinguishable. And there were some formulas proposed to assess this difference by formulas for arbitrary colors. So let's see the first formula proposed by International Commission for Illumination. It's called CE delta E 2000, where CE is International Commission on Illumination. And we can see that the color distance is described by the following equation, and it takes into account many parameters such as lightness difference, chroma difference, hue difference, uses correction coefficients and weight function, and rotation function for correcting the direction of the ellipse. So here we see the comparison between McAdam ellipses and delta E 2000 ellipses. And for visualization purpose, I have enlarged them 10 times. And we can see that in some areas, they have different direction. For example, in blue area of spectrum, and it's the most common problem in the area of color science, which has been noticed before. So let's take a closer look how we calculate these values. First of all, we transform RGB color space, which is widely used for interface design and computer graphics, to CA-X-Y-Z color space using following matrix. And then we apply nonlinear transformation to transform it to CLab color space. This color space is called uniform because it's more corresponding to human perception, and the ellipses are more similar to circles in this color space. So for this purpose, we use function f, which is nonlinear and uses condition for this x value. Here we have an overview of the three color spaces considered, and we can see that with this transformation, we achieve more complex shape, which is not just a cube as RGB and is more difficult. So it can represent human perception of the color. Another color space considered is CAM16 uniform color space, which is recently proposed in the year 2016. And here the delta E between two colors is described by Euclidean distance, which is more similar as delta E. However, it's difficult to transform to this color space, so it lays out of the scope of my paper. And if someone wants, I have mentioned this in the references. And for comparing these formulas, there is a metric called stress, standardized residual sum of squares. And the more little this value is, the better is the formula. We can see that CAM16 can more accurately predict the color perception, and is this formula delta E is the measured difference by formula, and delta V by people and de facto measured value. Also, let's consider the measurement of color differences for color blind people, or also called people with color vision deficiency. It was discovered that they cannot distinguish between colors that lay on these lines called confusion lines, which are running through confusion points, which are different for different color vision deficiency type, named protanopy, ditanopy, and tritanopy, for each of 3 color channels. And for practical purposes, we use not these lines, but transformation using matrix of color vision deficiency, which can predict the color which is perceived by these people. Now let's take a closer look on the software which I have developed for this paper. It can measure 2 colors on of arbitrary part of the screen. We can select delta E formula among the 2 considered and the vision type. Also, we can choose the aperture size, which allows to measure the average color in this area, and then calculate the delta E, which is shown here. Here we can see the color points, which show the color coordinates in CLab color space mentioned before. For practical evaluation of my application, I chose Le Courrier eligibility table, which is widely used for design purposes. And we can see that the higher value, higher color combination is in this table, the better it is. So black on yellow is the best, and red on green is the worst one. Also, some authors use color contrast metric instead of this metric, which I have proposed for this purpose. And it's calculated as the relationship between 2 luminosities of colors. I have done experiment with this table and measured the values for each color combination. And we can see that yellow and black color combination, which was the best in the table, received not the best results for each metric. Instead, white and black was the most contrast colors. So from this table, we can make a conclusion that the better contrast doesn't mean that this color combination is better. Also, we can see some differences between values in delta E and CAM16, which are caused by ellipse shapes. They are wider or thinner in these equations. To conclude, this paper proposed a new approach for objective color combination assessment. For further work, I propose creating a software which allows not only to measure the difference between colors, but also its ranking based on statistics from user experience. The results of this work can be already used to measure if the user can see a difference between colors or no, which can be useful in situations when we need to choose a background for image. Thank you for your attention. If you have some questions, ask me.
Thank you very much. Please, dear colleagues, your questions. Andrei. Well, my question, can the delta E metric be considered a sufficient objective creation on its own? or should it be combined with other parameters?
Okay, I think that it can be considered as objective for small color distance as a measure if we can see the difference between two colors. But the experiment shows that for large color difference, we need to combine it with statistics of some amount of users.
Okay. Well, another questions? All right. Thank you, Andrei. Thank you for your presentation. And I invite next presenter. Next report, Intelligent System for Analysis and Assessment Population Health Harm Risk by Air Pollution Level. I can find any authors.
Mykola Rudnichenko.
Mykola, yeah, yes. Mykola Rudnichenko, are you ready?
Probably connection issues. Andrei Mykolaievich, can we this speech attempts to make later. I will try to contact this team.
No. Okay. Thank you. I'm here. Just a little delay because internet. I'm sorry for the delay. Yes, I'm here. Thank you.
Okay.
I'll show the screen. One moment, please. Can you see my screen?
Yes.
Yes. Thank you. Dear colleagues, thank you very much for the opportunity to present the material. Our team from Odessa National Polytechnic University want to present you our work called Intelligent System for Analysis and Assessment Population Health Harm Risks by Air Pollution Level. Let's start from problem relevance. In recent decades, rapid industrialization, urban growth, and the whole intensification of anthropogenic activity have led to significant degradation of atmospheric air quality, actual ecology problems, particularly in densely population areas. The health consequences of prolonged exposure to air pollutants such as fine particulate matters, for example, PM 2.5 and PM 10, and different other bad air elements that can cause the risk of people's health. So despite the growing body of epidemiological research highlighting the causal relationships between air pollutants and health outcomes, the implementation of intelligent systems capable of assessing health risks at the population level remains undeveloped. So we haven't got any full stack complete systems which can provide the whole pipeline of data analyze, data research, and maybe some prediction skills. There is a critical gap between theoretical models of health environment interactions and practical applications capable of processing heterogeneous, actually big data in real time, accounting for spatial and temporal variations, and providing personalized of community-specific risk assessments. In this context, the present research aims to contribute to the field by developing an intelligent system, full-stack system, designed to assess health risk levels in population based on air pollution exposure. The purpose of our article paper is to build a scalable and interpretable framework system that not only predicts health risks with high accuracy on machine learning models, but also assists in the formulation of target innovations and policy decisions. So it can be useful in to help compare and support decision making. And there are different work objectives, and you can see which you can see in this screen. Let's start from problem and solution. As I said, machine learning actually and deep learning are the base of our model research, including deep neural networks and assemble frameworks, especially assembling frameworks that offer super capabilities over traditional statistics by modeling complex non-linear relationships and handling high-dimensional multimodal data. These models can predict pollution levels, estimate exposure risks, and model disease incidence. However, we got a little experience to use these models in our past projects caused with health risks and virus analysis. However, the field faces significant challenges. Many machine learning applications are experimental, require robust real-world validation, and need interdisciplinary collaborations. Specific research showcases high accuracy air quality prediction in papers of different authors using XGBoost assemble algorithm and LSTM natural network, or links particulate matter concentrations in respiratory visits via multilayer perceptrons demonstrating feasibility. Despite technical progress, a gap remains between studies focusing solely on pollution forecasting, prediction, and those that directly integrate health outcome assessment for comprehensive and context-aware public health decision-making. So we can confirm that modern analysis systems leverage machine learning techniques, deep learning techniques, for data preprocessing, feature extraction, and predictive modeling in many cases. It's trained and validated on integrated datasets combining environmental sensor data and health outcome indicators. Unfortunately, that's a big problem to find out and structuring the real data which we can collect by our own. So we need to build the prototype of the system based on ready data set. We can have it on Kaggle or different data set repositories. Actually, we used air pollution image data set from India and Nepal. It's not really modern, but it's kind of good structured and can be useful for training models as for classification and for regression. This dataset comprises a collection of more than 20,000 annotated images capturing varying levels of air pollution in urban and rural environments. To enhance the reliability and generalizability of the model outputs, the dataset was further extended because 20,000 20,000 rows, it's not so much, and validated using structured environmental measurements from two authoritative sources. We combined this dataset with two more widely structured data sources. also that were given from Kaggle. The problem under our research can be formulated as a multi-class classification task, firstly, and regression task, secondly. In machine learning, multi-class classification refers to a predictive modeling problem, as you can know, in which the algorithm must assign an observed instance to one of several predefined classes. In our case, it's 6 classes. And we propose a hybrid concept which introduces scientific novelty through the structured vision of interpretable and deep learning models into a unified analytical system. We combine different models to have a hybrid result, which can provide us the higher level of accuracy and different metrics. And we can see on this slide, there is a systems pipeline, the general concept pipeline. We can see machine learning models, server backend, and web frontend, because it's a full stack application. We used Python, we used Flask framework, we use React on the front end for develop user experience, user interface. And we have a backend the bouquet of different libraries such as sklearn, keras, and numpy, pandas, and so on. We built our concept on these stages as load data, save data set into local storage, metadata, making EDA, exploratory data analysis, process data for predict, visualization, saving results, and model research. Actually, visualization is the last step before we print different ways to calculate to predict different results of predicting health risks, and which is used for decision support making later. And session ends on it for the user. We can see on this slide the components diagram. It's not all the components, it's just general. And we can see that there are different classes like regression and classification, which used different serialized models in pickle format, PKL. We built and we trained and built and test 6 different models, as we can see. Decision tree model, the general machine learning model, random forest model, assemble model, XGBoost model, the most interesting model in our research. Also MLP model, a multi-allele perceptron, LSTM model, and a deep natural network model used by Keras. The natural network models were serialized in Keras format. Also, we use grid search to combine to find out the best values for the hyperparameters for natural network models. On this slide, we can see system project code structure, which we can see the API that folder, which have classes, some of classes, not all. Helpers to work with database. It isn't presented here because it's kind of simple database. It just have 2 tables with data and sessions. And we can see the folders of models of classification and regression where we store our serialized models. And server pi as a main server script. On this slide, we can see the first part of systems dashboard user interface. We can see the table of imported data from file or within user interface fields or tables, and we can download a CSV report which has EDA results. We can see some of visualization for which shows us some of statistics of the data set. We can see on this slide the second part of user interface. It has different parts. I show here only two, which also show us some of EDA results as grouping data by AQI class for classification. And for visualization correlation metrics between our features, the most important features, which we can calculate based on PCA method to make our dataset a little bit shorter if it is really too big. And after we can see on this slide some of our research results as models confusion metrics for our models. DT is decision tree, XGBoost, RNN, LSTN. I'm sorry, it's a mistake, not RNN, but LSTN, and CNN has a deep DNN, deep neural network. We can see the results are quite closer, except DT, decision tree, it's the worst model. And XGBoost has a little bit, on confusion metrics shows that XGBoost model is not so great in accuracy as CNN, for example, but it's very it's better in performance, in time of using. We can see on this slide the general ROC and models comparison results based on different experiments. And we can see on this slide that XGBoost violet color is actually one of the best result, has the best result. And also the generalized and aggregated results of research of metrics for the classification task is accuracy, precision, recall, and F1 score, and average time in seconds for training model. We can see that the accuracy of XGBoost is about such as CNN LSTM. In couple of experiments it was lower, in couple it was higher, and the most interesting that it has not really much time performance, only 8 or 9 seconds instead of 45 and 67 for the DNN and LSTM. And we can say in conclusion, as a result of the research, it can be noted that the comparative evaluation of implemented models demonstrated a clear advantage of ensemble and deep learning models. The XGBoost classifier achieved the highest overall accuracy of about 0.993, with corresponding precision is also about this value. Among deep learning models, DNN and LSTM also performed at a high level, in about 0.98. These results indicate the system ability to correctly classify the health risk level in over 98% of cases when using the most effective architectures. In addition to classification accuracy, computational efficiency was accessed through the average model training time. Simpler models such as DT and RF, random forest, exhibit lower training times, 3 and 7 seconds respectively. This difference between simple models and ensemble and deep learning models uncovers a typical trade-off between model complexity and execution speed, for which is really critical for production way to explore the system and use it in real time. Nevertheless, the super predictive performance of the deep learning models justified their use, especially in scenarios where accuracy and robustness are critical. And our system can provide the features when we can choose which model we want to use. And it depends on the volume of data set we can import or load for the analyze. Reliability analysis using confusion metrics and ROC curves confirms the stability of predictive across all 6 risk classes. Furthermore, expanding the system's scope to include individual-level risk personalization and summarization of long-term epidemiological trends would further increase in practice value for public health planning and policy support. Thank you for your attention. If you got any questions, please.
Well, thank you. Colleagues, please, your questions. Sergey Alexeyevich. Well, my question. You mentioned that the unification of data stream, for example, satellite images, ground station data, etc., is a significant upscale due to differences in structure, resolution, and formats. What methods can be used to convert heterogeneous data into coherent formats?
Thank you. Thank you for the question. Actually, it's a good question because we have different views on this for decisions this problem. Some of the authors proposed the way which we just live with these features and do not use it. Some of them wanted to scale it into, for example, one resolution. No, for example, pictures were converted in 2025 to 224 pixels as a dimension. But in our work, in our research, all the heterogeneous volumes of data were included in our data set as a metadata. We, on a stage of PCA, when we find out which features are the most important, we discovered that these features can be compressed in one general feature of heterogeneous, which can be classified in 6 classes. Not the target classes, 6 risk classes, but the 6 input feature classes. So we just transform it within the PCA, all the generators features into one and mark it from 1 to 6 integer, from 0 to 5, 0, 1, 2, 3, 4, 5 category, and insert it in our final data set, which we used for training and testing our models.
Thanks. Maybe anybody have another question? Okay. Thank you, Mykola, for your
Thank you very much.
And I want to invite next authors. Denis Markevich, Svetlana Kryvyi. Вибачте, excuse me. Kryvyi, Irina Spivak, Roman Kryvyi. Okay, Denis. Well.
Okay, 1 second. Do you see my presentation? Do you see my presentation?
Yes.
1 second. Yeah, okay. Today I would like to present our research approach to assessing the impact of motivation on employee performance in an inclusive environment. Second. Inclusive education is becoming a crucial direction for modern educational system. In Ukraine, in 2020, about 163,000 children with disabilities were registered, but only 78,000 actually receive education. Many still study in segregated schools far from home, while families consistently report difficulties such as accessibility, lack of adapted materials, and insufficient professional support. One of the key challenge we highlight in the low level of motivation among teachers who work with children with special educational needs. Their work require emotional resilience, flexibility, and additional time, and the level of motivation greatly affects the quality of inclusive education. This is why our research focused on understanding which motivational factors influence teachers most and how these factors affect their overall performance. Okay, here is some graphic about this situation in Ukraine for now. Motivation in an inclusive environment is highly individual. The same stimulus, whether financial, social, or psychological, may influence two teachers completely differently. Some educators are driven by a desire to help a child grow, while others rely more on external incentives, such as recognition or compensation. Therefore, identifying which motivational group is dominant for each employee is essential. This helps educational institutions support teachers in a targeted, personalized way and increase their effectiveness when working with inclusive children. In our study, we classify motivational needs into three major groups. Material needs such as salary, additional payments for inclusive work, rewards, and compensation for extra workload. Second one is social needs, including recognition, opportunities for professional growth, the ability to propose new methods, and feeling of social value. And the last is psychological needs, such as teamwork, support, flexible work conditions, participation in professional events, and opportunities for self-realization. To assess the influence of motivation on performance, we defined 5 key performance indicators for teachers. It is qualification, effectiveness, initiative, self-development, and adaptability. Employees filled out questionnaires indicating how strongly each motivational factor affects each performance indicator. We then calculated weighted performance values using the coefficients. 0.5 for social factors, 0.3 for material factors, and 0.2 for psychological factors. These weights reflect the importance of social motivation in inclusive work. The result is a sorted set of the most influential performance indicators for each employee. This helps managers understand which motivational factors should be strengthened to increase a teacher's effectiveness. Here is some visualization, like a table of one of our university teacher, which set a mark of every of this category, and later this data we use in such a graph to visualize this data. And we implement this to the system. To automate this method, we develop the software system Spark, which stands for survey platform for assessing responsive knowledge. Spark allows educational institution to conduct automated surveys among employees, visualize motivational curves for each teacher, generate personalized profiles based on performance indicators, and provide managers with detailed insight into which needs require support. This system simplifies monitoring motivation over time and helps make data-driven decisions to improve performance in inclusive education. And here is some prototype of this system. It is a screen of setting a mark, and it is a screen of admin who later see all the data of mark of teachers. And to summarize, it is important to conduct regular surveys to understand the needs and motivational levels of teachers working with inclusive children. These results should be used to develop targeted strategies that enhance their professional effectiveness. The methodology also enables the creation of a psychological profile for each educator, helping managers better understand their readiness and personal goals. Thank you for attention, and I'm ready to answer your questions.
Thank you, Denise, for your presentation. I attempted to return with some internet and other resource constraints. We all in some constraints environment. For example, disruption in energy, disruption in salary, disruption in motivation, etc. My question, how does the ongoing war and its psychological impact both on teachers, students, affect the applicability of your motivational assessment model? We see an exciting chart for the 4 authors of this paper, highly motivated person. But reality check can be addressed some other issues or not.
Okay, but our system is created, is a first step to our bigger system, which will in future, in future, these teachers who is highly motivated will be work with such children with some disability, and I think we will only allow only a high motivated teacher work with such students. So it's this system created to check and find such teachers, to work with such students.
Thank you for your answer. I see at least 2 issues in this research. First of all, it's your motivation model. Yes, it's a classical development of Keller model, but Keller work in Florida, Agricultural Institute, etc. in United States. Moreover, his model was developed almost 40 years ago. We live in Ukraine. So, how do you plan to validate your assessment methodology with a larger, more diverse sample of educational professionals? For example, what statistical methods will you employ to ensure the both reliability of your motivational assessment framework and generalizability, particularly given the complex nature of inclusive education needs and ongoing work.
Can you please repeat because I have some internet?
Denis, you build your software based on the theoretical assumptions, your assessment model. But your assessment model was validated only on the very limited set of educational professionals, you and 3 your co-authors. So you attempted to build a practical implementation on the possibly not improved, not tested model. I ask you, how do you plan to test your assessment framework to make the appropriate changes in your software?
Okay, later we plan to make a research not only for of us, but also in other university in Ternopil and later in all country. So we plan to give this.
Thank you. And my last question, I now see your paper. You have assigned fixed weighting coefficients, 0.5 for social, 0.3 for material, and 0.2 for psychological, across all constants. Have you any empirical evidence that support this very specific weighting? Or at least how these weights were banned. It's only a theoretical assumption one of author proposes, and you say for psychological 0.2 is a good weight, and we will work. Oh. No, your theoretical grounds, I hope that will be improved. The solid ground, the solid fundament, we need to make the solid empirical and our software. Thank you.
Okay, we invite for next presentation Andriy Baran. I see. Are you ready?
Yes, I'm ready. Just a sec. I will share my screen.
Okay.
So I hope you can see.
Yeah.
Hello, my name is Andrew, and I'm a master student in software engineering at West Ukrainian National University. This work was prepared with Irina Spivak and Svetlana Krapich, and the topic is LLM and MCP-driven e-commerce assistant over graph databases. E-commerce is a huge industry with very high revenue, but recent study shows that there exist big losses as well. Almost $2 trillion $2 trillion every year because of incomplete purchases. More than 70% car adaptment of shopping carts are missed, and around 80% of users do not return after a bad product search experience. The main problem is poor customer experience in navigation and search. Users often did need to know exact product names or understand the store category structure. Every store has a different taxonomy, and it becomes very confusing. On mobile devices, it even harder, a small screen, many steps, and users usually give up before finishing. Our proposed solution is to use an assistant. It reduces the whole interaction to a simple chat interface. This gives a user experience similar to speaking with a consultant in physical store. One entry point, easy search, and comparison of products, and better recommendations based on context. The idea is not new. Company like Amazon and Walmart already experimented with it, but recent progress in LLMs, improvements in graph databases, and the appearance of MCP protocol now make such system more realistic for production use. The goal of our work was to build a proof of concept architecture where LLM communicates with user as an assistant and builds its answer using real and fresh data, and not limited to fixed API or queries. The model generates its own database queries during chatting with user. So architecture overview. We used Venture. It is not just e-commerce framework and PostgreSQL as transactional e-commerce backend. You can see this on the diagram in this part. The AI service is a separate module on the under GraphQL layer, API layer, and has own database. And sync service. So why do we need another database in this flow? Because the LLM must generate the queries by itself, and and why it is a graph database. And graph database naturally describes the relation between entities. For example, bought together, belongs to a category, has facet, and it's used for filters. And graph databases much better handles complex query, which can be generated during user in LLM interaction to return better results for user. In relational databases, the same query would require many joins and could be slow. And generally, second database can be scaled independently, filled only with specific data, which improves security, stability, and scalability in whole system. But still, primary all e-commerce data in primary database Postgres. So we need some way to move data from one database to another, and we build it as a synchronization pipeline. E-commerce plan any e-commerce transaction change data in primary DB PostgreSQL, and PostgreSQL generates binary logs. Pipeline based on DBZone and Kafka reads these logs. DBZone analyzes events and forms events for Kafka, and Kafka acts as event storage and queue and streams these events to a dedicated processor in our code already. Which create this operation for Neo4j database, second database like add, update, delete, node, and relations. So the graph database becomes updated almost in real time. And now we have data in graph database, so we can connect LLM. For the prototype, I used Sonnet 3.5 with a basic prompt and 2 MCP servers. MCP is a key component here. It gives the LLM a controlled API, validates a generated query, and limit actions, so the model cannot do anything unsafe with our data in graph database. It becomes very limited. I used MCP Cypher to get a graph schema and execute Cypher queries, so users' intent can be converted by LLM to flexible queries, and which will be used to get data for user by LLM. And second, MCP server, MCP memory to store LLM dialog context directly inside the graph, so we have multi-step conversation on the UI. How it looks in flow. The system receives the user message and redirects to LLM. The LLM identifies the user intent and gets context of dialog from MCP member server. If the intent requires product data, LLM gets the graph schema from another MCP Cypher, and based on this graph schema, generates queries that will be used to get data for this user intent. So then LLM generates a Cypher query and executes it via MCP. MCP calls Neo4j and returns the result. The LLM uses it to form final answer. Before sending the answer to this, the system performs an additional check if the answer matches a query and the query does not reveal extra data, answer is returned to user. Also, AI service can update on context about user preference via MCP memory server. But for the user, it looks like a simple chat. And inside the chat, this chat model fetch user preference on first message, collect product data on second and third message. You can see about question about where user planning to run, like gym, road, trail. It's about categories. Foot size, it's also about characteristic of shoes, and color, brand, it's also about categories. So LLM clarify user intention, ask additional questions. User gives answer, and then LLM fetch products which can be useful for user and gives final answer. Yes, results. As a result of this work, we got proof of concept architecture between LLM, graph database, and MCP servers, and traditional e-commerce system like microservice architecture. Also, we got a pipeline where data is captured from PostgreSQL and change via pipeline and wrote to Neo4j graph database. LLM powered exploration. LLM fully interprets intent, select appropriate MCP tools, generate Cypher queries for fetching additional data. And it works without predefined scripts in our code. Also, usage of graph database allows us to execute much complex queries without performance issue, and generally, as it is like microservice architecture, we got graceful degradation, traditional AI remains fully functional if AI fails. So if something went wrong in AI part, users still can use search, use filters, and shop still available for user, because generally AI nice tool, works well, but we cannot fully rely for now. And scope implementations. It was proof of concept with production ready approach, production ready components like bench and L4G, MCP. But still there are some additional steps that should be done before going to production. We need better prompt engineering because quality and security of a system heavily depends on prompt. We need performance testing, and performance testing with production data, with production catalogs, with concurrent users. So it requires much more time and efforts for it. And we need to confirm that users, that customers would be happy to use it this way, because yes, generally we need user survey, A/B testing, to confirm that this way is better for customer experience than traditional commerce. And one place for optimization is graph, because if we analyze more user intents, which queries usually are executed, we can build a better graph, which will allow LLM build simpler queries, and general LLM will much better understand this graph. So thank you for your listening, and I'm waiting for your questions.
Yes, we have a lot of questions. Thank you for your presentation. I start with my first question. On your last slide, you indicated regarding A/B testing. At the moment, you propose, no, at least in your demo, a classical conversational interface. Now, for example, a real customer. I don't remember which my food size. I can't say what is this color. I don't know his even title of this color. I don't know the title of some shoes, etc. As a real customer, I want to see, put a finger. Oh, yes, it's those that need to me. Even when we use a conversational interface like Viber, Telegram, chatbots, etc., we should propose at least some alternatives like menu-like, button-like interface, some choices, not only for clear conversation. But this rather reflection. My question regarding a current idea, AI must be everywhere. First of all, you have some window, for example, for Claude. 900,000 tokens, 900 kilo tokens we have, and we have different categories of your customers. Balabol categories that can make a long, very long conversation, etc. In Cloud Code that I use, we have an exciting ability when the context window, free context, will shorter, we will try to compact it. Instead, to save all conversation, some main remarks. If such conservation techniques you plan to realize, or you attempt to make a slider window all context, but we forgot what was in the beginning. Which your strategy?
Generally, there is session-based approach when we store context during some short time about conversation, because it's e-commerce and user there is a quite small chance that user will return to this dialogue again. It just like their necessity to get some information, to get some help and moment. So session-based approach can help. We store just messages during this chat. But still,
moreover, it will be more cheap. You can use the models with a small context window, free or cheap models. Thank you so much. My next questions, what, as a real customer, suspicious customer, I don't like that my conversation and my personal data will be saved and will use it to for my future dialogues. What about privacy?
About privacy, at least we steal some data in our system, so we can guarantee some part of privacy in our system. But AI, in this case, in my proof of concept work, was third party. So at least we need to get confirmation from user that he's ready, that a part of data can be shared. Or another way, try to replace third-party LLM with some how to say, self-hosted component, or some service that generate that guarantees privacy security. Like, for example, in Europe there are GDPR, if I'm not, if I am right. So something between can be, or try change this component by something self-host, or try better provider that can guarantee security, data privacy, and still ask a user if he is ready, if there is ready.
Thank you. And my last question. The main idea of use the language model is that the user patterns will be quite stable. But in consuming, we have a lot of trends. Today I want Labubu. Tomorrow I will try Bubu. Next day Lala, etc. How you will try to augment your input for your model by these fast changing, trending components without full model retrain?
It's not really depends on model, because in this architecture, model is like orchestration on
and you
top.
can propose as a separate MCP server, for example, the current trends that augment.
Can be. We can connect different tools to this.
Yes. So in this case, there are really current trends, current politicals, current war, and something current can be augmented on today user input and propose the best goods for it. Even, for example, last night was the rocket attack in his or her city. In the morning, he or she would like to forget about this and want a goods, with там, sugar or with щось another that can be anti-stressing goods. I know my colleagues that even at the time of rocket attack go to Rosetka another and try to make some some selling activity. It's not not selling, buying activity. So it can be one more idea for which can be MCP infrastructure that fully involve your customer in this activity.
Generally, I like this idea about connect this to real world, but for me, it looks a bit complex for our step of LLMs and MCPs because we need connect our system to real world data. And we then must analyze user geography, recent trends, recent news, and it's much complex. But there is another way. We can compare trends in our system. We can see that some products sales much better than a few days ago. Some products started be shared with another products. So I like this idea, but I believe for now it may be better be only inside our system.
Thank you, Andrei. Thank you for human intelligence conversation, not artificial intelligence today. But I'm sure for another questions to this exciting presentation. Any questions? What? No questions. I'm sorry, Andrei. But we need to go the next talk. Thank you very much.
Thank you. Thank you.
And our next presentation will be dear Maxim Petrovich. I'm happy to see you.
Thank you. Now I'm sharing my screen. One moment, please. Could you see my presentation?
Yes.
Good evening, colleagues. My name is Maxim Kosey, and today I present our research, comparative analysis of UAV simulation platforms, challenges, opportunities, and future directions. This work was conducted in collaboration with Andrei Kupin and Yuri Asanchuk from Kryvyi National University. The use of unmanned aerial vehicles is rapidly expanding. As this system become more autonomous, the need for simulation grows exponentially. We highlight three critical reasons why is better use simulation software against of the real world simulation. If you conduct experiment in real world, you got some problem. First of all, it is costly. Real world testing requires significant expenses, hardware, maintenance, and so on. Also, it is risky. Testing new algorithms, especially for swarm robotics, risk hardware damages. And last but not least is time consuming. Real-world testing requires permits and specific weather conditions. So it is, in my opinion, it's better use simulations before providing real world experiments. But first of all, let's decide requirements for an ideal simulation platform. First of all, such platform must ability to simulate different variety of UAVs. Also, this platform must count the variety of the sensors and provide and also simulate realistic weather conditions, such winds, turbulence, and so on. And in this time, it was popular swarm intelligence, and such simulation platforms must support a variety of communication protocols and swarm routing. And during writing our articles, we summarize critical limitation for the modern simulation platforms. First of all, it is fragmentation. There is no single universal platform exists. Researchers are often forced to combine different tools. For example, Gazebo with Network Simulator 3, which dramatically increase development complexity. Also, another problem is the reality gap. This is the most important issue. Inaccuracies in physics and aerodynamics, like realistic wind modeling, inevitably lead to algorithm failing in the real world. And also, simulators struggle to accurately emulate realistic factors like sensor noise and GPS errors, resulting in a model trained on idealized data. And the last challenge is scalability. It is extremely difficult to maintain high fidelity, accurate physics and sensor data when simulating large swarms of hundreds of UAVs in real time. This limitation demonstrates why further research and standardization are essential. The future of simulation lies in overcoming this limitation through strategic innovation. Our research identifies four case opportunity. Breaching the reality gap, the solution is adopting digital twins, hyper-realistic virtual replicas of physical UAVs, precisely modeling their complex physics. Also, standardization and benchmarking. To address fragmentation, the community must focus on a single unified framework for objective, repeatable platform comparison. Also, scalable swarm robotics. Future platforms must significantly improve their ability to simulate complex network constraints, latency, packet losses, and so on, while handling thousands of agents without sacrificing physical accuracy. And we must use specialized solution. We need deep streamlined integration with special AI machine learning tools, particularly deep learning reinforcement for efficient controller testing. During writing our article, we analyzed dozen scientific works and articles for the period from 2016 to 2025. And we noticed there are hundreds of different tools existed. So we must to choose must major and must divided platform. It is consists of of 5 simulation platforms. Gazebo is the de facto standard for robotics research. Its simulation platform has deep integration with robotic operating systems, which used in many modern drones and UAVs. Another interesting simulator is AirSim from Microsoft. It help to achieve a beautiful picture and high-level photorealism. Webots is interesting platform, most simplest, as I think. It's all-around tools offering a strong balance on features and crucial swarm support, directly aligning with my research focus. And MATLAB Simulink swarm simulators is a critical tool for control design and swarm algorithm development. And Capella Sim is also powerful tool focused on physics and complex modeling. Based on our comprehensive analysis and the identified gaps, the direct focus of my dissertation is the development and testing of swarm intelligent algorithms. This required a platform optimized specially for this task. Therefore, I selected 2 key platforms for in-depth use, Webots and Gazebo. Our selection based on the 4 principal key criteria: scalability, guaranteed support for large numbers of agents, open source, provides essential accessibility, code transparency, and full customizability, OS compatibility, support for Linux or Windows operating system, and activeness. Regular updates, active GitHub repositories. I confirm these platforms is updated in 2025. I check it. So on this slide, let's conclude our research achievements. First of all, our analysis establishes the 2 primary systematic barriers: critical market fragmentation and the persistent reality gap. And also we achieve a practical achievement. I choose a tool for my future dissertation. I select Webots on Gazebo simulation platform. Also, we make contribution to the community. We created an objective meta review and methodology. And I hope this comprehensive framework with other researchers in platform selection, speeding up technology adoption. And our work identified the urgent need to focus future development on digital twins and improving deep deep learning integration to ensure reliability of AI algorithms. We used different AI tools. We used LSCTI for finding relevant research papers and conducting the initial literature review. Also, we used large language models such as GPT-4o and Gemini, and we use it for ensuring grammatic and spelling check, providing formatic assistance, and paraphrasing and rewording complex concepts into clear, concise languages for this presentation. And this slide concludes our presentation. I thank the conference organizers and committee members for this opportunity to present our works. I also thanks to my co-authors, Andrei Kupin and Yuri Asachuk, and Kryvyi National University for their guidance. We hope this objective review will help another researchers and scientists. Here you can see our contacts. Thank you for attention and patience. And now I'm ready to take any question you may have.
Thank you very much, Maxim Petrovich. As your co-author, I have a conflict of interest, so I ask Andrei Mykolaievich to ask his questions.
Today, UAV technology is activity developing, and many experimental designs be implemented. Does the complicate the standardization of simulators that you propose for future research?
It's very complex task because of variety of the solution. When I read articles devoted to the sphere, I count about hundreds of the simulations, simulation platforms, and open source solutions have many forks, and I think to help to standardization is provide more conference and workshop. People must share their experience one with another to achieve more rapid advancement in the swarm intelligence and UAV.
Thank you, Maxim Petrovich. And as despite the conflict of interest, I would not ask any questions, but my some recommendations regarding your research. First of all, the part of your research is a cutting-edge research. So when you use LSCT or another tools, they use as is outdated data, outdated papers from half year ago, etc. So my choice when I would like to make some software, first of all, integrated AI tools for the most prominent databases. In Scopus, I recommend to use the Scopus AI. I clearly tested that even papers indexed a day ago are already in the result. In Web of Science as a research assistant, but most prominent approach. I today make some conversation in the chat regarding the Journal of Edge Computing. Some days ago we completed with a comprehensive survey based only on preprints, 2,000 papers from preprints that automatically, without AI tools for analyzing, but with AI tools for creating related software to extract metadata and further search by usual keywords. It can, when you use a preprint server like Arxiv, you can achieve a high productivity because the most prominent ideas are in this field, are in preprints. Moreover, in Arxiv, a lot of papers related to software, repository, etc. No, it can at least strengthen your research. Moreover, try to at least open one of papers that I recommended. At the end of paper, full repository with software for scanning Arxiv, how it can created, how can we automate such analysis, etc. For example, introductory paper, editorial with such software was created less than a week. With no, quite small efforts comparable with the classical software. So automate, and one more time automate. Thank you very much.
Thank you
Dear
for
colleagues.
valuable advice. Thank you very much.
Any other question to Maxim Petrovich? No questions, so who our next presenter? Andrei Nikolaevich.
Next presenter, Yulia Sapsa. I welcome.
Thank you. Okay, I'm gonna share my screen now. Could you please accept the request? Okay.
You can share your screen.
Yeah, I'm trying to. Okay. Can you see that?
Yes, excellent Canva and your window.
Okay, 1 second. Oh, okay, you can see the presentation, right?
Yes.
Okay, let's get started. So, good afternoon, everyone. My name is Yulia Sapsa, and today I am presenting our work titled Design and Implementation of Modular Animated Agents in VR using inverse kinematics and XR toolkit. So this project was developed at the Ukrainian National Forestry University in collaboration with my colleagues Oleksiy Sienkiewicz and Alexander Storozhuk. Our research focuses on building reproducible and modular pipeline for animated VR characters using open source tools such as Blender and Unity. So virtual reality is increasingly used in simulation and training, which raises the need for realistic and responsive 3D characters, yet current VR tools lack a clear, reproducible pipeline for integrating animated characters, especially in low-cost or educational settings. Our work proposes such a pipeline combining Blender for characters creation and Unity with a XR toolkit for real-time interaction, supported by a modular architecture and a functional VR prototype. So in this project, we combined open source and industry standard toolkits, tools that are Blender, basically Unity, C# and XR interaction toolkit, and Collider tools. In the workflow, low-poly humanoids characters were created and animated in Blender, then exported as FBX files with the full skeleton data, and Unity was chosen as the main development environment due to its strong VR support and the XR interaction toolkit, which enabled controller input, object manipulation, and event handling. So all interaction logic was scripted in C# using Visual Studio Code, and for testing, we relied on the XR device simulator, which allowed us to validate interaction behavior without requiring a VR headset. Okay, moving to the next one, the formal model of the virtual scene. So in our system, the virtual environment is defined as a dynamic model consisting of 4 interacting components: the player agent with full head and hand tracking, a set enemy of NPCs, and a set of interactable objects such as weapons, spatial trigger zones defined by colliders. And each element has its own state space, and interactions occur through event-driven state transitions, which allows to formalize and control the behavior of the entire VR scene. So the virtual environment is constructed using a low-poly aesthetic, which minimizes geometric complexity while preserving the spatial clarity required for interacting tasks. And a modular component-based architecture is applied to ensure efficient interaction handling, scalable behavior control, and responsive animation management. And the scene is structured around the core spatial zones. So a player spawn area, an interaction-ready weapon station, a dynamic trigger zone, and also an animated humanoid agent used as reactive target. And this configuration provides a focused and controllable setup suitable for procedural testing and iterative refinement. The architecture also follows a modular component-based structure where each element of the scene is controlled through dedicated scripts, and core components include modules for hand input processing, projectile instantiations, NPC behavior management, and also a trigger-based activation. And interaction is also driven by XR controller tracking, enabling real-time head and hand movements. And when the player enters a refined trigger zone, basically the NPCs transition from idle to an alert state, illustrating event-driven logic and reactive animation control. So these interaction models relies on XR-based grab mechanics and custom C# scripts that bind controller input to projectile creation. When the user also pulls the trigger, a projectile is instantiated and simulated using Unity's physics engine, and also the full interaction cycle is organized as a finished state machine, covering object acquisition, aiming, firing also, and collision response. And this FSM structure ensures predictable behavior and simplifies also debugging and real-time VR scenarios. Okay, let me move to the next one. The character model also is created in Blender using a symmetrical low-poly modeling. And the mirror also modifier across all axes, it ensures full geometrical symmetry, and also it reduces manual adjustments, while clipping maintains a clean mesh topology. And after the base mesh is basically completed, the skeletal rig is added to prepare the model for animation and subsequent VR integration. Okay, in the character was modeled in basically Blender using symmetrical low-poly techniques to maintain clean topology. A human meta rig was then imported and anatomically aligned to the mesh, and with recalculated normals, ensuring correct joint also orientation. And afterwards, also each bone was precisely positioned in edit mode to match the character's anatomy and enable natural deformation during this animation. And after bone alignment, the mesh was bound to armature using automatic weights, generating the vertex basically groups needed for smooth deformation. And Riggin then established the hierarchical bone controls and rotation limits and constraints that ensure anatomically plausible movements and allow the characters basically to perform naturally and to have a stable animation during a runtime. In this stage, then various kinematics were added to the arm and the legs, basically allowing characters to perform joint movements naturally with a minimal basically manual control. And after rigging three core animation states, the idle, the alert, and death were created in Blender and exported to Union at FBX files with embedded skeleton data. And inside the Unity, an animator controller mapped gameplay events to states, basically different transitions, such as switching to the death animation or upon projectile collision, ensuring a very consistent and reactive behavior during the runtime. So in this work, basically, a complete VR development pipeline was implemented, also combining Blender, modeling, rigging, and the animation. With Unity's C# or scripting as well, animation, FSM, and XR toolkit. And the prototype basically demonstrates the stable real-time interaction, also responsible animation, and a scalable component-based architecture. And the system successfully also synchronized IK, skeletal constraints, and event-driven logic, making it also more suitable for education, simulation, and VR prototyping. And the future, of course, improvements might include the richer NPC behavior, the dynamic IK, the multi-agent agent AI, and usability evaluations. So that was it. Thank you so much for your attention. If you have 1 second, if you have any questions, I would be happy to answer them. Yeah.
Thank you very much. Have anybody any questions, dear colleagues, for this interesting report?
It seems to be today a day of silence. It seems to be tomorrow will be some elections, etc. A completely silence in auditory.
I mean, the topic is quite different, so maybe that's why there is like little to no questions, but it's okay. Yeah.
Well, I have some questions.
Okay.
You use low polygon models, maybe to save resources. Are there any other objective advantages to such models?
Well, I think using low-poly modules, for example, for the first time when we are creating projects, are pretty usable because, for example, this game can be used for students or, for example, in kids, and using the low-poly also models would help them the game feel more interactive, more easy to handle. Of course, in the future, it could be used the more high-end animation as well, and the difficulties could be also changed. But for now, I think as this project goes, we were aiming to create something more interactive, for the people to understand everything, and using those low-poly models would help them to understand basically the game more clearly, So yeah.
And another question. Judging by your interaction model, only interactions between the player and game objects are provided for. Can we expand the model to include interactions between game objects themselves?
Themselves. Well, I think it could be all.
Sorry.
Graphics, but it's really interactive. In the future, when the project of course is improved, and you can see a lot of games on the internet, that they have more complicated sources, and of course it can be integrated in this game precisely. And I think it could be, of course, in the future when we have more time, for example, to develop a more complicated game, just to expand the mobility and the compiles of the program, basically. Yeah.
Okay, thank you. Thank you very much for your report.
Thank you for your questions as well. Okay.
Well, and I want to invite next presenter.
Regarding using artificial forests for our real forests.
Yes, you're right.
Okay.
Hello, I am Oleg Chaskovsky from the Ukrainian National Forest University. I represent some team, and Andriy Necheporenko is present here. Maybe he can help me if I don't know some specific events, but now I want to present this our work. This work is done in frame of some project, Everzone project. And it's connected to forest and to forest cover change and to some artificial intelligence method to define these changes. And now we have this challenge, a big challenge in the Ukrainian forest. Especially in Ukrainian Carpathian, as a very forested region, mainly forest is situated in Carpathian and in Polisia. And this is a big region, and climate change is affected on this forest. And we need to know what is the value of this forest? How much is this influence on our forest? And we have here anthropogenic activities, illegal logging and another logging, and some disturbances caused of climate changes. And we know that forest health stability is very important in this region, because we have here a lot of soil erosion and another natural disturbances and disaster. And traditional monitoring methods are limited, hindering timely detection of disturbances. And we need a robust data-driven monitoring framework for this sustainable forest management. And we try to make some system to detecting forest cover changes, especially in Ukrainian Carpathians, especially in some natural park, Skolivsky Beskidi, and we use different satellite images and advanced machine learning and deep learning method. And now to our yes, area. You know that this area is situated in the west of Ukraine. It is a mountain area, and size is more as 30,000 hectares, and forest cover is huge. It's about 90% of cover is forest, and here grows very different species, forest species, beech, fir, and spruce, and we have here a lot of places where recreation and also the management zones, because the forest and wood is very values product for our industry and our economics. And we need to now very fast these changes, and because we need to now how decision need for forest management government, how and another decision policy maker, forest maker, and ecology, and another government organization. And now to satellite images. We used radar satellite images, Sentinel-1, and optical Sentinel-2. This is a multispectral images, and
I'm sorry, Oleg Grigorovich. I think you would like to show such images to our auditory. Can you share your presentation?
Excuse me, it was my fault.
It happens.
Yes, this is about introduction and problem and challenges in Ukrainian Carpathians. Here is the maps and about Ukrainian Carpathians situated in Europe. And here is the west of Ukraine, and now we have these borders of Skolivsky Beskidi National Park. Okay? Yes, you see now. Do you see
Yes,
now?
thank you. Yes.
Excuse me, that it was only the maps, and now we have this our satellite images and description of satellite images. We have this combination of satellite images, radar satellite image, Sentinel-1 and Sentinel-2 optical Sentinel image. There are the multispectral optical image. This is Sentinel-2 and have different resolution 10, 20, and 60 meter according to band, and there are the free satellite images. We can get it for free, and it is very important because we need to have some system to get near to to this time information, and we use the digital elevation model. It is very important because of landscape. Landscape is mountain because this is Carpathian, and without this model, without this additional information, it is very hard to get some good maps. And now we can get these satellite images for free, and we use this Google Earth engine for this task, and we had this training and validation date. We had 700 random selected point forest and non-forest and validation data set in there are the 300 points, and as we see here, this point from left it is for classification, and right is for validation point. And about methodology, we use two models. One model was this is first model deep learning algorithm, and here we have this workflow of our work, and we use here the PTORCH segmentation model and another. And for the data preparation, we use mainly the Google Earth engine, and for data preparation and for get the satellite images. Yes, we have this workflow, and we use second algorithm. It was random forest classifier is good for forest classification because it needs not a big amount of this training training points, and here for this algorithm we used Google Earth engine and this classifier Smile Random Forest, and we choose 50 decision trees, and we classified two scenes. We created two maps for 2023 and 2024. And by comparing these two maps, we get the change map with the classes very shows where very forest, and after that were non-forest. It shows the places with changes, and we calculated accuracy and kappa coefficient. Here about this is deep learning methods. We use here Python and PyTorch framework, and here we describe this method, but yes, yeah, you can see it and read it. It was technical questions. Oh, excuse me, it was. And wall architecture is combined from the Google Earth method and these satellite images and prepared satellite images, and then we detected these changes in the forest cover, and we use this API, and after that and the finish, we use this front end at website using Cloveral and October CMS. And this information are displayed on this website, and some accuracy. We compare this accuracy, deep learning method, deep learning model had a little bit better accuracy assessment, and here we see that deep learning significantly improved boundary delineation and reduced noise effect compared to random forest. But at the end, we compared our change map with forest management map, and we now here this numbers shows this compartment and subcompartment from forest management map, and the user now knows what where is the this forest cover loss or disturbances, and very in very short time, and we can say that it's near to real time monitoring, and system product some message, some alert message for the government, and he or they can react on these disturbances, on this forest cover loss very quickly, and they can observe these places, because it can be not some felling or clear cuts or another illegal logging. It can be natural disturbances like fire, forest fire, or another thing. But anyway, they should to react very quickly to reduce this negative effect on the forest, on the system, or environment at all. And we have this discussion and contribution that Sentinel about some satellite images, Sentinel-2. These Sentinel-2 images with deep learning they have a big power for this definition, or for recording of this forest distribution, especially in Skolie Beskid. And we use additional information. It was this SRTM digital elevation model. It is very important to use this information for satellite images interpretation, especially for mountain region. And accuracy was high, and this WebGIS platform is very good for decision makers, because we can get this information very quickly, near to real time, I can say. And we, for example, for wall Carpathians, we can spread this system and to make some monitoring system for this region of Carpathian, or for Ukrainian forest region at all. And conclusion, because we have this free satellite images, and we can get these satellite images relatively in time, and near to real time. It can be one time per month. It's enough for the this interpretation, and it's good that we can organize this satellite image interpretation with Google Earth Engine, and with this algorithm. random forest and deep learning. Random forest is available, this algorithm in Google Earth Engine. Deep learning model we use in another in Python, but this model can be integrated in such in those system monitoring system, and it can be mm, very good for decision maker. They work in the field of forest management on or ecology or another government organization. Thank you for attention, for your attention, and I can answer on your question. Yes, thank you.
Thank you very much for such comprehensive talk. I think a lot of questions that can be drawn from this research. It's rather not a question, it's some ideas, probably proposals, etc. No, for example, the first you use an industrial standard. Regarding the accuracy, inference time, etc. UNet is a really good approach. Probably can I think it's only probably for your task can be used no some kind of visual transformers, but for your conditions when we use only binary classifications, and in fact you don't need a very big accuracy. It's good. Even the random forest approach that you use that you indicated as not so exact as you need, low kappa coefficient. No, it's yes, it's a moderate agreement, but you even when you get some kind of false negatives, no, it's a reason to investigate some areas that you segmented with another method. I think a really good approach when we make a big decision, a big picture, using fast running random formulas that you can achieve from Google Earth Engine, and and exact solution by the user's request using UNet and appropriate convolution networks that you use. In fact, I really have no questions to your research, but it was interesting for me. For example, some personally new, Google Earth Engine already propose API. I don't know this. Thank you for your such additional good information for that. But it's a much of words. Andrei Mykolaievich, I think have a question.
Thank you.
Well, a small question. In your study, you used several data sources, which is entirely reasonable. But did you evaluate the contribution of each source and its impact on the final result?
Yes, we use the satellite images and addition the digital model, digital elevation model for this mountain, and we make this special resolution for the Equals special resolution, and we use this set from optical channel. It was optical channel red and infrared, and one channel from radar satellite. Radar satellite is good because it is not independent on the clouds, on the weather, and digital elevation model. But all this component, all this band were resembled to the same special resolution, 20 meters. And this 20 meters was comparable to make some data set. Yes, yes, it was the answer. Maybe it's
okay, thank you.
okay. Thank you for the question.
Maybe we have another questions. No questions. Well, thank you very much, Oleg.
Thank you too. Thank you for the invitation. And it is
very interesting and very good research.
Pleasant for me.
Well, I want to invite next presenter. I see Alexander Mazurets.
Good afternoon.
Good
I'll be
afternoon.
the presenter.
Good
My name
evening.
is Shrepa. Can you see the screen?
Yes, yes.
Today I'll present the work on the SIM deep learning method for UAV detection and flight path forecasting in real time. Nowadays, unmanned aerial vehicles gain a lot of popularity. They're used in both civilian and military purposes and correlates with United Nations Sustainable Development Goals such as number 9, 11, and 13. Unfortunately, there is a risk of unauthorized use, which leads to goal 16. The problem of detection drones is not new. It's usually solved with radar or acoustic sensors, but when we talk about small-sized UAVs, it's better to use computer vision models that can detect, track, and even predict trajectories using video data. The problem of prediction UAV trajectories is critical for timely decision-making in systems of counteraction, support, or prevention of potential threats. However, most of the existing research focuses either on the problem of detecting objects in static frames or on tracking their position without taking into account the dynamic characteristics of the movement. Methods that combine spatial-temporal processing of a video stream with trajectory forecasting based on the history of observations remain underdeveloped, particularly in cases of maneuvering or chaotic trajectories. So the development of a method for neural network detection and forecasting of UAV trajectories in a video stream is a scientifically and practically relevant task that will contribute to increasing the efficiency of situational awareness systems, critical infrastructure protection, tactical support, and autonomous navigation. The aim of the work is to develop the method for forecasting the trajectories of small-sized UAVs in a video stream based on a modified positional encoded transformer architecture, taking into account the history of movement and special constraints of the scene, which provides a reduction in the average and final prediction error compared to statistical models and retains its suitability for integration into real-time monitoring system. The main contribution of the work is the implemented modification of the transformer architecture for forecasting the trajectories of small-sized AUVs, which allows to preserve the model's ability to contextually match observations while reducing computational costs. On the slide, you can see a pipeline of the method. At start, we have a video source. It can be 3 times video file, URL, or stream. From the source, we get frame, which goes to detection model YOLO V12. Detection results goes to tracking algorithm by track, and tracking results are saved into repository. When we have enough historical data for prediction, data from repository goes to transformer predictor, and predicted trajectory is saved into repository. Then it's shown, frame and bounding boxes are shown on video player, and the predicted trajectory on a moment map. To predict trajectories was used modified transformer architecture. The exclusion of a full-fledged decoder block and its replacement with a coordinate-oriented module with positional encoding ensures the constancy of time dependencies without losing spatial binding. Such restructuring of the structure made it possible to reduce the dimensionality of intermediate representations and reduce latent fluctuations that usually arise when working with short and fragmented tracks. An additional result was an increase in the forecasting accuracy by using windowed coordinate aggregation with a fixed alignment horizon. This allowed to compensate for nonlinear changes in the trajectory and reduce the final error without involving complex recurrent components. The use of sinusoidal positional vectors instead of embedding layers improved the model's resistance to noise, large-scale fluctuations, and loss of part of the frames, which is typical for real-time video streams. Dataset anti-unmanned aerial vehicle was used. It contains around 600,000 annotated video frames in complex observation scenarios, such as disappearance of object from the field of view, change in scale and illumination, partial or complete overlaps, low target resolution, and rapid movements. To test the method was create experimental setup. Its application written on Python. Kryvyi was used for interface, OpenCV to work with images, PyTorch for neural networks, and cloud resources from Kaggle were used to train models. Now on the slide, you can see results of the detection. A high value of map 50 shows accurate positioning of the bounding boxes, while the map 50-95 ratio demonstrates that the model retains adequate sensitivity even with increased matching criteria. Working speed is enough to work in real time. You can see here confusion matrix. On the right side, it shows typical situation for detection task when background is not annotated, so we have no values of true negatives. Tracking results of by-track algorithm shows MOTA and IDF1 metrics higher than in most modern research for statistical methods. Working speed is enough to integrate into monitoring systems. Lower in the table, you can see prediction metrics. There are RMSE, which is loss function, ADE, which is average error, and FDE, which is error in the final point. Here, these values are in pixels. If we talk about size of the image, it can be said that it's 1% of a typical image width. On the right side, you can see transformer training loss function graph, which shows a rapid decrease in loss function around during first 25 epochs, and then it stabilizes. On the slide, you can see examples of the method in action. A program interface shows on the left side image and bounding boxes. On the right side, there is detected drones panels, and in the right corner, you can see map which shows previous trajectory, current point, and future predicted trajectory. Now you can see trajectories comparison graph, which shows with the black color historical trajectory, with the green color real future trajectory, and with the red color predicted future trajectory. And it shows that model can predict simple linear trajectories as well as more complex. The comparison with classic methods was conducted. It was a model based on Kalman filters, and the results shows that transformer has an error smaller by an order of magnitude. Going back to a slide with detection results, there was a confusion matrix that showed a significant amount of false positive detections. They were all analyzed, and the results show that a significant portion of such observations correspond to objects with similar structural or silhouette features, in particular aircraft or drone-like structures, which in real conditions may also be of interest to the monitoring system. Under these conditions, the behavior of the model demonstrates its sensitivity to potential relevant targets rather than random error generation. Conclusion. A method for neural network detection and prediction of UAV trajectories in a video stream has been developed, combining detection, tracking, and transform prediction in a single processing pipeline. An AI system has been built that's capable of forming continuous trajectories of small objects in complex observation conditions and generating short-term forecasts with an RMSE error of 12.66 pixel, approximately from 25 to 32 centimeters in physical space. The proposed approach provides MOTA equals 0.79 and IDF1 equals 0.64 metrics, which exceeds the published performance of most modern solutions based on statistical models. The speed of 332 FPS on the CPU confirms the possibility of integrating the method into applied monitoring system. Work has limitations. Among them, forecasting is performed in two-dimensional image coordinates, which corresponds to the conditions of stationary observation of a fixed camera. Only a short-term prediction horizon is considered. This approach is justified for operational monitoring systems, and increasing the prediction interval will require combining it with behavioral models or probabilistic estimates of uncertainty. A separate area of development is the adaptation of the model to different types of dynamics, from translational motion to complex maneuvering models, which can be implemented through preliminary classification of trajectories or multimodal forecasting. Thank you for your attention.
Thank you, Masik, for your presentation. I will start from one question. It's now time don't ask a question. So one only question. In your report, I see you use a famous anti-UAV. It seems to be a data set. It was a single data set, or do you try to you modify a transformer architecture with another data set? What about in common? What about the generalization? Two different types, size of a hull, flat patterns, etc., that were not presented in ATUV datasets.
This model was trained only on this dataset, but there was some tests on examples of frames from another data sources, and models showed high accuracy too.
On frames, so you have at least 1 second sequence of frames to make prediction.
Yeah.
Thank you. Any other questions? A day before elections. I'm sorry. Andrei Mykolaievich.
One question for me. This is a very, very timely study. Your work focuses on short-term forecasting. How can the forecasting interval be extended? And will this require the integration of behavioral models or estimators of probabilistic and currently maybe another.
Yeah, thank you for your question. To increase prediction interval, we should at first increase historical data, and it's harder to predict huge amount of time ahead, so we can't be so sure about larger periods, so we should need to use some behavioral models or probabilistic models here. So it will be maybe we have a probability that the trajectory will have such maybe appearance with such probability or such appearance with another probability. So it will be harder to say that trajectory will be so and
Okay, thank you. And next presentation.
Again from Khmelnytsky.
Again, Maxim.
I'm C. Alexander Mazurets, or who will be presenter on the next talk. Olga Zabuska.
Okay, please.
So do you see my screen? Is everything okay?
Yes, yes.
Thank you. So good afternoon, dear colleagues. My name is Olga Zabuska, and I'm pleased to present you today the topic deep neural network-based classification of textile macrostructures by synthetic to natural fiber ratio by authors Alexandra Mazurets, Olga Zabludska, Marina Molchanova, Valeria Klimenko, Lyudmila Bukhantsova, and Oksana Zakharkevich. So the textile industry faces major environmental challenges, especially in recycling mixed fabrics. Determining the extractive ratio of natural and synthetic fibers is essential, yet traditional analytics methods are slow, costly, and destructive. Advances in AI and computer vision offer non-invasive alternatives for analyzing fabric structure. This study explores whether macro-level fabric images contain enough visual cues for accurate deep learning-based classification of synthetic fiber content, supporting sustainable practices and UN Sustainable Development Goals number 9 and number 12. And here you can see the approach of classification of textile macrostructures by synthetic to natural fiber ratio. As you can see, fabric samples are captured with the microscope to reveal fiber structure. Images are then preprocessed and passed to a customized deep neural network. The model classifies each samples into one of three groups based on synthetic fiber content. These are from 30 to 50, from 50 to 70, and from 70 to 100%, and output was the predicted class and the confidence score. This provides non-invasive, accurate, and stable alternative chemical or spectral analysis. And here you can see why actually we determined especially these three categories. This because this reflects both market distribution and practical recycling needs. The fabrics that contains from 30 to 50% of synthetic especially polyester fiber, these behave mostly like natural fibers and can be recycled mechanically with minimum quality loss. The fabrics from 50 to 70%, these such transitional zone where natural and synthetic properties balance. These materials are the most difficult to process and require combined thermomechanical or solvent-based methods, making precise identification crucial. And the fabrics that contains more than 70%, these are high polymer fabrics, are suitable for chemical recycling or energy recovery, and accurate composition estimation helps optimize the composition and polymer resynthesis. And a couple of words about dataset creation. The dataset used in this study was independently created based on our previous study. It consists of three classes according to the percentage of synthetic component in the fabric. You can see at the top of this slide the fabrics marking samples. All these photos are real and obtained by the authors from the real products. So you can see the stamps on the fabric samples from the shop, for example, and on the other part you can see fabric samples with different percentages of synthetics. You can see 3 different classes. And shortly about information technology for neural network classification of textiles by percentage of synthetic components. So the first stage is dataset transformation because we already had previous dataset divided by natural and synthetic classes, and we just a bit transformed this dataset. The second stage was models training, then models evaluation, and fabric level classification using best trained model. And here you can see the basic developed experimental software for neural network textile classification. And a couple of words about results. So you can see here the results of training models on validation data and the confusion matrix for best performed model. So here you can see that results show stable learning without overfitting, and validation confirmed real generalizability across different textile textures. V2B16 achieved the best performance, outperforming efficient B0 and convex tiny due to its ability to capture global structure patterns while self-attention. And also, the hardest class to classificate was transitional class from 50 to 70 with symmetric arrows towards neighboring intervals. And this classification occur mainly in the transitional group where textural features naturally overlap. And no cross errors between the lowest and the highest classes confirm correct interval choice and robust model behavior. And in this table, you can see comparison of the obtained results with analogs. The proposed method demonstrates higher performance compared to existing textile analysis approaches. A key practical advantage is the ability to classify specific intervals on synthetic fiber content rather than performing only binary fabric identification. And while some traditional high accuracy methods rely on complex and expensive spectroscopy, the presented approach achieves even higher accuracy using only a standard digital microscope, making it far more accessible for industrial and laboratory applications. So the study confirmed that macro-level fabric images enable higher accurate determination of synthetic nature of fiber ratios. To develop a workflow from dataset creation to model training and evaluation demonstrated that with B16 model provides the best performance, reaching 98.2% accuracy score, outperforming both CNN-based and spectral analysis methods. The model successfully classifies fabrics into 3 synthetic content intervals, making the approach practical for recycling, labeling control, and material sorting. Although effective, the results reflect standardized imaging conditions and homogeneous samples. Real-world factors such as variable lighting, defects, multi-layer structures, and borderline compositions may affect performance and require further testing. Future work includes dataset expansion under diverse conditions, revealing interval boundaries, integrated uncertainty estimation, and deploying the model in industrial sorting systems. This result supports the development of accessible AI-based tools for textile recycling and circular economy practices. That's all. Thank you for your attention.
Thank you very much. Please, your colleagues, questions.
I have or questions, remark probably. You use classical structures like textile, and the main strength of convolutional neural networks is that we can catch by this network the related patterns. Textile patterns is quite simple. So probably a simple convolutional network, a shallow network, we can achieve from it the same results like from this very complex architecture. Do you compare with a simple convolutional network on this data set, not with classical convolutional architectures, etc., or not?
Thank you for your question. I'll just skip to previous slides. So here you can see the samples from our dataset. Actually, we conducted a little investigation about binary classification, synthetic or natural materials, and then we compared simple models like simple CNNs and so on. And then we realized that simple architectural models are not good enough for these patterns because, as you can see, even on these pictures, synthetic or natural fibers are really complicated to recognize. Even the slightest differences in types of types of knots in these fabrics can
I
almost break
understand.
down the
The
system.
main problem is three classes that hard to differ. Oh, I'm sorry. I understand. Thank you. Any other
Thank you.
questions? No question. So really, visual transformers will be a good approach for the patterns which differ quite small, like on your data set. I'm sorry, I don't understand your main idea from the scratch.
Thank you.
Thank you. Thank you very much. And I invite next presenter. I see Lesia Bulatecka.
Bulatecka.
Greetings. I'll present the next article. So give me a second to share the screen. Oh, here it is. Can you see?
Yes, yes.
So the topic is hyper-encryption algorithm and its implementation in .NET. Authors are Danila Zolotopukov, Lesia Bulatecka, and Vitaly Bulatecki. Presented by me, Danila Zolotopukov. Let's begin by defining the current state of secure communication. In the modern digital world, we rarely use just one type of encryption. Instead, we rely on hybrid architecture. As illustrated here, the landscape is divided into two main families, symmetric and asymmetric algorithms. Individually, they have limitations. Symmetric algorithms are incredibly fast but require a pre-shared secret. Asymmetric algorithms solve the key sharing problem but are too slow for massive data transfer. Therefore, the standard solution today is to combine them. We use asymmetric algorithms to securely hand over the key and then switch to symmetric algorithms to encrypt the conversation itself. This synergy is what currently protects the world's data. Now we'll take a brief look at some of the most popular algorithms. Let's focus first on the symmetric component of the hybrid system, AES, standardized by NIST in 2001 under FIPS 197. It serves as the global benchmark for securing data at rest and in transit. Whether in government, banking, or commercial sectors, AES is trusted because of its proven, tested by time cryptographic strength and computational efficiency. At its core, the algorithm is based on the Region-Dale method. It operates on fixed data blocks through a sequence of operations: byte substitution, row shifting, and column mixing. This structure ensures high performance while scrambling the data so that brute force attacks remain computationally infeasible. However, AES has one critical limitation due to its nature: symmetry. To decrypt the message, the receiver must have the exact same key as the sender. This creates the key distribution problem. How do we safely transfer the secret key over an insecure channel before the conversation even begins? And this problem is addressed by an asymmetric algorithm like RSA. RSA stands for Rivest Shamir Edelman, is a family of public key asymmetric cryptosystems based on the difficulty of factorizing the product of two large prime numbers, the factoring problem. RSA utilizes a pair of interconnected keys, a public key for encryption and a private key for decryption. This allows for secure communication via public channels without the prior exchange of the shared secret. It became a standard for public key exchange and digital signatures, securing critical data transmissions across the globe for decades. Despite its prevalence, RSA faces an increasing number of evolving attacks. Recognizing this vulnerability, NIST has officially announced its deprecation by 2030, with a full disallowance for 2035. So the era of RSA is coming to its end. And why exactly is RSA being deprecated? One of the most important reasons dates back to 1994, when Peter Shor formulated his famous algorithm. He proved that a powerful enough quantum computer could factor large integers exponentially faster than any classical supercomputer. This discovery effectively turned the hard problem that RSA relies on into a trivial calculation. Sources refer to the arrival of these powerful machines as Q-Day. On that day, the cryptographic shield protecting the world's digital infrastructure, specifically RSA and elliptic curve cryptography, will disappear. Also, there is a strategy known as harvest now, decrypt later. Malicious actors and state agencies are already intercepting and storing encrypted traffic today. They are accumulating this data, waiting for the moment they have the technology to decrypt it. This means that information sent today is only secure if we protect it against the computers of tomorrow. And we have a solution for this problem. In response to the growing threat of quantum computing, NIST announced a large-scale competition back in 2016 to find an algorithm capable of protecting our secrets in the future. From all the contestants, the Kyber algorithm emerged victorious and was officially approved as the new standard in August 2024 by paper FIPS 203. This mechanism is based on the mathematical difficulty of the model learning with errors, or MLWE problem on model lattices, considered resistance to quantum supercomputers. Designed for secure encapsulation and exchange of symmetric keys over open channels, it's planned to fully replace vulnerable standards by 2030. During our research, we identified that for the .NET platform, there was no official or native implementation of this new post-quantum standard. As for today, a few weeks ago, Microsoft released post-quantum cryptography implementations with .NET 10 release, though they rely on OS-specific libraries, so not every combination of software and hardware running the platform supports it. The goal of this work was to develop a custom library in C# built from the ground up. The objective was not just to make it work, but to ensure it strictly complies with the newly released FIPS 203 specification. Now let's look under the hood to understand the cryptographic mechanism we implemented. So let's take a look at simplified schema of Kyber's workflow. Note that here by domain parameters n equals 256 and q equals 3,329 are being used. Squares represent vectors and matrices where each value is a polynomial of degree n and its coefficients are rings modulo q. The process initiates with key generation. One party, whom we shall designate as Alice, selects a random public matrix A and selects a secret vector S. Also, she introduced an error vector E, representing mathematical noise, into the equation. This injection of noise converts a trivial linear algebra problem into the learning with errors problem. The resulting pair AT serves as the public key, while S is retained as a private key. Subsequently, and Alice transfers her public key to the other party, which is presented by Bob here. Subsequently, during the encryption phase, the sender Bob utilizes this public key to transmit his message M. He introduces his own entropy by generating a random vector R and additional noise vectors E1 and value E2. Then he computes two components, vector U, which mask the randomness, and value V, which efficiently conceals the message M within the mathematical noise. This results in the ciphertext pair UV, which is transmitted back over the open channel. And we conclude with a decryption. Alice uses her decryption key S, performing these computations to retain the message M. Now let's turn to our Kyber's practical realization. As identified in our research, the .NET platform lacked a native implementation of this standard. To address this, we developed a custom library. First, the class design. The library exposes a single entry point, the Kyber class. This class is instantiated with an enum value, which specifies a specific FIPS 203 parameter set, like MLKIM 512 or 768 or 1024. We used a stateless methodology. All the core cryptographic operations, key generation, encapsulation, and decapsulation are pure functions. By maintaining no internal state, we ensure thread safety and predictable execution, which is critical for high-load environments. Thirdly, the cryptographic reliability. Adherence strictly to FIPS 203 mandates for randomness. All entropy required for the underlying lattice problems is generated using the cryptographically secure generator system.security.cryptography.random number generator class. Finally, portability. The logic is implemented entirely as internal managed code. With zero reliance on native OS libraries or external dependencies, the library functions seamlessly across any hardware or operating system supported by the .NET platform, including Windows, Linux, macOS, Android, iOS. Let's take a look at a sample use case. This slide demonstrates the practical application of the library. Our goal was to make post-quantum security accessible without burdening the developer with the underlying mathematical complexity. As you can see, the entire workflow is considered into 4 logical steps. First, we initialize an instance with a predefined security level. This is done by both parties, of course. Next, Alice generates her key pair by just calling kgen method. Then Bob uses her public key to encapsulate a shared secret, producing the ciphertext. And finally, Alice uses her decapsulation key to decrypt that ciphertext and get her copy of the shared secret. And they're identical. Here you can see performance tests. To validate the efficiency of our implementation, we conducted comprehensive benchmarking across a diverse range of hardware. You can see 2 desktops, 2 laptops, and a single Android device. The metric here is decapsulations per second. This is the most critical metric as it represents the computational burden on a server handling multiple handshake requests. For different parameter sets, computational difficulty is different, so the results are different as well. To conclude this, we have examined the vulnerabilities of current asymmetric standards like RSA against quantum threats and identified the need for a native post-quantum solution in the .NET ecosystem. We successfully implemented a pure, fully managed C# library for the Kuiper ML-KEM algorithm. The solution is stateless, strictly adherent to FIPS 203 and independent of OS-specific dependencies. Tests confirmed the library's efficiency and scalability across diverse platforms, from desktop workstation to mobile devices. Future work will focus on integrating this library into real-world applications such as secure messaging systems and exploring hybrid encryption schemes. Thanks you for attention, and special thanks for reviewers of our article. Your feedback was really valuable for us. Any questions?
Thank you very much. My question. You mentioned that there is no official implementation of the Kyber algorithm for the .NET platform. Have any unofficial or third-party implementation been considered that could be used in .NET?
Well, I mentioned that there was no, like, it's not very actual for today. It came out a pair of weeks ago, but it's still limited. Though, there were already existing libraries which could be used by .NET in the .NET environment by pinvoke, for example, just calling outside libraries. Don't remember exactly. Probably Wolf SSL supported Kyber already, and I took a look at the source code. It was implemented in pure assembly language. Very hard to read. Well, there were some for sure.
Thank you. Maybe another questions? No question. Thank you very much for your research and presentation.
Thank you as well.
Well, and next presentation.
Good afternoon, everyone. I'm here to present our work on neuromorphic computing for cognitive radio systems. This represents a fundamental paradigm shift in how we approach wireless spectrum intelligence, moving from traditional digital processing to brain-inspired computing architectures. Let me start with the challenge we're facing. As we move toward 6G networks, we're encountering unprecedented demands for ultra-reliable, low-latency communication. Current AI-based cognitive radio systems typically exhibit latencies of 10 to 100 milliseconds. However, emerging applications like industrial automation, autonomous vehicles, and remote surgery require sub-millisecond response times. That's a gap of 10 to 100 times. The von Neumann architecture that underlies all conventional computing creates fundamental bottlenecks. We're constantly moving data between memory and processors, which consumes both time and energy. For cognitive radio systems that must make real-time spectrum decisions, this architectural limitation becomes a critical barrier. So where exactly does all this latency come from? We analyzed the processing pipeline of typical cognitive radio systems and found that AI inference dominates, consuming 40–60% of total latency. Feature extraction adds another 35%, while signal acquisition and memory access contribute the remainder. The key insight here is that the majority of latency comes from computational processing, not from fundamental physical constraints. This suggests there's significant room for improvement if we can reimagine how we perform these computations. This brings us to neuromorphic computing, a brain-inspired approach that fundamentally changes how we process information. Instead of the traditional model where we continuously process data through sequential operations, neuromorphic systems are event-driven. They only compute when something interesting happens. The key principles are, first, co-located memory and processing eliminate data movement. Second, massive parallelism allows thousands of simple processors to work simultaneously. Third, information is encoded in the timing of spikes, just like biological neurons. The result? Energy efficiency that's 10 to 100 times better than GPUs. This isn't just an incremental improvement. It's a fundamental architectural advantage. Several neuromorphic platforms are now available, each with unique strengths. Intel's Loihi 2 offers 131,000 neurons with on-chip learning capabilities, making it ideal for adaptive cognitive radio applications. IBM's True North achieves remarkable efficiency at just 65 milliwatts, perfect for battery-powered edge devices. The NeuroRec processor, specifically designed for RF applications, achieves the lowest latency at just 0.08 milliseconds. What's exciting is that all these platforms achieve sub-millisecond performance, meeting our URLLC requirements while consuming orders of magnitude less power than conventional solutions. Here's how a complete neuromorphic cognitive radio system works. The RF front end acquires signals, which are then converted to spike trains by the encoder. The neuromorphic processor performs all cognitive functions: spectrum sensing, interference detection, and allocation decisions, using spiking neural networks. The remarkable result is end-to-end latency of just 22 to 170 microseconds. That's not milliseconds, it's microseconds. We maintain 9 to 97.6% accuracy while operating at power levels suitable for mobile devices. This represents a complete system solution, not just a proof of concept. Let me put these latency improvements in perspective. Traditional FFT-based spectrum sensing takes about 30 milliseconds. Deep learning approaches improve this to around 12 milliseconds. But neuromorphic systems achieve 0.55 milliseconds on average, with specialized processors like NeuroRec reaching 0.08 milliseconds. That's 375 times faster than conventional approaches and 156 times faster than deep learning. We're not talking about percentage improvements here. We're talking about orders of magnitude. The energy story is equally compelling. A GPU consumes about 5 microjoules per operation. Edge TPUs brought this down to 25 nanojoules. But neuromorphic processors operate at 20 to 31 picojoules. That's 1,000 times more efficient than GPUs and 100 times better than edge TPUs. This isn't just about reducing electricity bills. This level of efficiency enables entirely new deployment scenarios, cognitive radios that run for years on small batteries, or dense deployments where cooling becomes impossible. Energy efficiency at this scale is transformative. One critical question is whether neuromorphic approaches scale to large networks. This graph shows spectrum allocation time versus network size. Conventional linear programming and deep Q-learning approaches quickly exceed the 1 millisecond URLLC requirement as networks grow. But look at the neuromorphic SNN line. It stays well below the threshold even at 100 users. The event-driven architecture means adding more users doesn't proportionally increase computation. This scalability is essential for future massive IoT deployments. These capabilities enable transformative applications across multiple domains. In industrial IoT, we've demonstrated 97.6% accuracy on real sensor data with sub-millisecond response, critical for factory automation. For autonomous vehicles, neuromorphic cognitive radio can adapt to rapidly changing spectrum conditions while maintaining safety-critical latencies. Defense applications benefit from superior performance in contested electromagnetic environments, while smart cities can deploy millions of sensors without centralized coordination overhead. Each of these represents billions of dollars in market opportunity. Of course, challenges remain. Hardware availability is limited, programming these systems requires new skills, and the software ecosystem is still maturing. Development costs are high and standardization is lacking. But the path forward is clear. We need continued investment in hardware-software co-design, better development tools, and gradual adoption starting with high-value applications where the benefits justify early adoption costs. Integration with 6G standards will be crucial. Let me conclude with 3 key takeaways. First, the performance benefits are proven. We're achieving 100x latency reduction and 1000x energy improvement while maintaining accuracy above 92%. Second, neuromorphic cognitive radio is a key enabler for 6G networks. It's the only technology that meets URLLC requirements at scale while operating efficiently in challenging environments. Third, this technology is ready for deployment. Multiple hardware platforms exist, the software ecosystem is growing, and we've demonstrated real applications. Neuromorphic computing isn't just an incremental improvement. It's a necessary evolution for cognitive radio systems. The convergence of brain-inspired computing with wireless communications represents a paradigm shift that will define the next generation of spectrum intelligence. Thank you for your attention. I'm happy to take any questions about our work on neuromorphic cognitive radio systems. For those interested in more details, the full paper is available in the conference proceedings, and I'm available for discussions during the break. Thank you.
Dear college, hi college. Today I'm very pleased to talk about an interesting topic about speed enhancement with the title Noise Reduction by using more reference signal in JSCAP beformer. As we know that nowadays microphone array technology is typical places. It's very common. It's loaded into various type of acoustic speed up application. Due to its convenience of using the priori spatial information, the preferred direction of arrival of signal, the characteristic of surrounding environment to often to steer the constant to steer the beam pattern toward the source. And the SCABI firmware is commonly integrated into numerous acoustic applications due to its effective performance in almost all recording scenarios. Because of the moving head of talker during conversation, the different microphone quality, the error of estimated steering vector microphone mismatch, the inaccurate sampling rate, the SCABI firmware evaluation often decreases. And in this contribution, the author proposed an effective way of controlling the steering vector to improve performance. And the alternate research has proven the advantage of the author proposed method in improving the robustness of the SCABI firmware in complex and adverse recording environment. And we can see that microphone array technology has been installed into different speed application. Figure 2 describes extracting the principle of extracting the desired target speaker by using microphone array. And figure 3 illustrated the schema of microphone array signal. And then the SCABI former the main signal ES and reference signal ER is the output of the upper branch and lower branch, and it can determine it as the equation 3 and 4. And the adaptive noise-canceller filter is an essential core of the SCABI former structure, and the Wiener filter often used for calculating the optimum coefficient by using the auto and cross-power spectral density between ES and ER. And the promising CSKB formula can be derived as in figure H in equation H. And the auto suggested technique, the auto idea is to generate more reference signal to improve the effectiveness of Wiener filters in reducing reminded noise. And from the described formulation received array signal, we can easily calculate additive reference signal with the following equation 9 and 10. And by using the priori information of the preferred direction of arrival of interesting useful signal, and the author used more additive reference signal to increase the SCABI firmware. And by applying more additive reference signal, the final output signal can be derived as in equation 17. And the experimental research, figure 7 describes the waveform of the original captured signal on microphone, and figure 8 and 9 illustrate the waveform of the processed signal by the SCABI firmware and by using the author proposed method. More and figure 10 describes the energy, the compared energy between this signal, and table 1 describe shows the improvement in the term of signal to noise ratio between this signal. And thanks for the attention.
Next presentation, it's my presentation. It's correctly? Yeah. Well, one moment. One moment, please. I see the slide of presentation.
Yes.
Okay. Okay. Well. I see, all right. Okay. Finally, I would like to present to you our humble project, a computer game, or rather a visual novel dedicated to the origins of software engineering. It is well known that the discipline of software engineering emerged from the NATO conference held in 1968.
This conference was a response to the challenges posed by the so-called software crisis. Sorry. It was then that the need to review attributes and approaches to software development become apparent. It was necessary to identify and develop engineering approaches to the creation of complex software systems. We devote considerate attention to this event in the course Fundamentals of Software Engineering. All reports and discussions that took place during the conference have been carefully documented by Peter Nauer and Brian Randall. The documented proceedings provide a good overview of the issues facing the industry, the main challenges, and the directions of solution. However, studying these materials in such a dry form is somewhat difficult and a little boring. It would be much more interesting in immersive students in the event of conference, and this immersion can be provided by a computer game. The basis of such a game, of course, is a well thought out plot. We drew inspiration for this concept after studying photographs from the 1968 conference. These materials contain photos of all participants, world-renowned IT specialists of the 16th. Each photo has a caption. However, there are also photos of participants who could not be identified. This is probably because they were little known, but seriously interested in software engineering. This inspired us to create a story about a young programmer who faced with problems in software development, goes to the first conference on software engineering. There he hopes to find answer on his question. Among narrative-driven computer games, the visual novel format is particularly effective. Numerous studies confirm the usefulness of visual novels for interactive presentation of educational materials and coverage of historical events. Notable examples include games such as Attend 1942, Venti Messi, Golden Twins, and many others. Therefore, we dedicate to present our story about the creation of software engineering in the form of a visual novel. Based on this idea, we designed a plot structure. The game begins a fictional American company called Software Services. Our hero is the company's lead programmer, but he faces numerous difficulties. To find a solution to his problem, the company director sends him to a conference in Garmisch. There, the hero meets various participants, witness discussions, and asks questions of leading experts.
Upon returning to the company, the player must make a number of key decisions. If the player has been paying close attention to the dialogues at the conference, they will make effective decisions. If not, the decisions will be wrong. As a result, one of three endings can be achieved: a lost opportunity, particular success, or first software engineer. After the general design, we moved to the writing the plot in details, turning conference materials into lively dialogues would be a titanic task even for a team of experienced screenwriters. But modern artificial intelligence tools came to our aid. We use the Notebook LM application, which is based on the large Gemini language model. First, we ask the model to analyze the conference materials, and then we give it a series of requests, such as creating a discussion between a young programmer and Edgar Dijkstra on the topic of choosing software development tools. It should be noted that the results were far from ideal, but it took much less effort to refine them than to write such dialogues from scratch. The main events of the game take place in Garmisch, in the Sonnenbeach, I don't know, hotel, where the conference was held. No photographs of the hotel premises from the 1916s have survived. However, there are many modern photographs from which the conference room can be clearly identified. Therefore, we again used artificial intelligence to recreate the 16th aesthetic based on the modern images. We took a similar approach to character generation. First, using real photo, we converted them into color images with the help of the Nano Banana model. These color images then served as a basis to create characters with different emotions and gestures. We couldn't find a real floor plan of the hotel rooms, but this wasn't essential for our visual novel. Therefore, we roguely constructed a floor plan so that the player could move between locations and see which character they could meet there. We also had to reduce a number of characters. There were about 40 participants at the conference. Interacting with so many characters could tire the player. Therefore, we reduced the number of characters to 9, who were selected based on their key reports and the most interesting discussions. After creating scenes, characters, and text fragments of dialogues, we were able to move directly the game development. The game begins with a conversation with the director of software services about the problems faced by programmers in 1916s. Schedule violation, rising development budgets, frequent errors, and unreliable software. The director sends the hero to Europe to attend a leading conference so that he can learn to apply engineering approaches to development. At the conference, the player meets famous personalities. They can with them in dialogue mode, ask various questions, and listen to the discussion. Upon completion, the player returns on the company where they can have put their acquired knowledge into practice and apply engineering approaches to their team's work. Therefore, we plan to use the visual novel we have created as additional interactive material in the Fundamentals of Software Engineering course. However, it's quite possible that it will be of interest to wide range of users. Some technical improvements to the game are still underway, after which we plan to make it available as a web application. We are also planning experimental to determine students' interest in this form of presentation educational material. We hope that the results of this experiment will help us determine the feasibility of using visual novels in other educational situations. Thank you for your attention, and I will be happy to answer your question.
And
Yeah,
who will... Oh, yes, at last, Danilo.
Sorry, I have a pair of questions here. Firstly, I didn't hear what technologies did you use for the actual visual novel? For me, from the screenshots, it seems like RenPy engine.
Yeah, exactly. It's a RenPy engine we used. Well, maybe any questions?
One only question. When we will end this workshop?
Maybe it's now. Maybe, Sergey Alexeyevich, we talk 4 words workshop. And it's problem in my internet or not?
I can hear you loud and clear.
Sergey Alexeyevich.
I'm sorry, very limited connectivity and energy supply. Andrew Mykolaievich, my question was about is it not time to finish our communication, at least for today?
Yes, yeah, exactly. Maybe щось ще скажете на завершення. Можливо, вже неофіційно.
The time is late, so we really need to finish this workshop, but I think it will be a good idea to continue our communication on the next event. No, at least Andrei Mykolaievich some weeks ago proposed to establish a satellite event. What the title? A doctoral consortium or PhD symposium for our students, PhD symposium in computer science and educational technology. Oh, yeah. I'm happy to announce that we really try to establish such a symposium in classical variants that in not such in horizontal in horizontal pose with a glass of wine that we discussed our problems in our doctoral theses, etc. Today we have almost 20 talks. Detecting minds with AI, teaching children with AI, protecting our forest with AI, building security system without AI. But almost all our today presentations were using artificial intelligence techniques, artificial intelligence everywhere. But we must use its response responsibly and understand the limitations. The best research in computer science is research that combine an reality tech and our real world experience and simulations. Simulation in good testing on laboratory data sets is a good preparatory talk stage, but we need to compare what in the real world is really our algorithm will be useful on the uncleared and hard world data. But I believe that today presentations and discussions help to at least and deep our understanding. Probably increase your ability to defend your result from our partially provocative questions. some of your presentations were new, both personally as and scientifically. The novelty is a key to our advances. Today we have not a good conditions, limitations in all senses, in internet connectivity, energy supply, but today only one presentation was pre-recorded. So we have live communications. We are live. Our computer science is live too. So we will be working. I thank you everyone for your asked and unasked questions, for your engagement, for your preparation to today's workshop, for your commitment. But you know, this process was a hard for all, for the hosts, for reviewers, for organizers. But we are resilient, stay strong, stay curious, and keep working. Ukraine and world need scientists like you. So, this workshop is closed, but we will see next year. I hope for a fourth time that will be in a peaceful Ukraine. Thank you for all, and Андрію Миколайовичу, давайте вже українською завершимо.
Thank you. Дякую. Так, мені в гарний день важко висловлювати думки експромтом англійською, а під кінець важкого робочого дня сьогодні було багато заходів. При дуже жорстких лімітах електрики. Я щиро радий, що нас було сьогодні так багато, що всі приєднались. Так, звичайно, з різних причин вже деякі учасники і відключились, але ми все чудово розуміємо. І п'ятниця, і вечір, і взагалі труднощів, перешкод нам вистачає. Але ми їх долаємо. І наснагу долати перешкоду кожному з нас дають якраз колеги, які поруч або віддалено, але теж на одній хвилі з нами. Працюють, досліджують, рухаються далі і підтримують один одного. За оцю підтримку я всім вам вдячний. Бажаю всім вже традиційно миру, наскільки це в наш час можливо, безпеки, стійкості, ну і удачі в вашій роботі.